Hey, we're starting in 2 minutes, so if everyone could get seated again. Can everyone get seated again? We'll start in 2 minutes. Yeah. Okay, our next speaker is Vrajaraja Govinda. He will talk about how he uses LaTeX at his ashram, if I pronounce it correctly.
Hello.
Good luck.
Audible? Hello. Vanakkam. Namaskaram. Namaste. That's all I know. So, my name is Vrajraj Govinda, and I am a monk at the International Society for Krishna Consciousness. For short, we call it as ISKCON. Some of you might have heard that name. I am going to present my experience with the LaTeX, and specifically with the Z-LaTeX of late, and how I got introduced to this software, why I use it, and how we use it in our ashram. First of all, I would like to thank the organizers, especially STM docs and the tech user groups, for coordinating the whole thing very nicely. And my special thanks to Carl Berry. Is he here? No. Watching it. He was the one who encouraged me to give a talk. Otherwise, I just wanted to attend this event. So, some 15 years ago, I was a postgraduate student at the National Institute for Technology, Karnataka, one of the premier technical institutes in India. And that is where I came across this software, LaTeX. One of my senior friends, he said that it is better to learn, especially for mathematical typesetting. It's very easy to write the equations and other stuff. So that's how I started learning that software. Initially, we had a book by Leslie Lamport, and at those days there was no GitHub and those things where we can just copy paste the code. So I just kept the book near my side and I was typing it manually on the computer and checking out what is text BF, what is text IT. It was a very nice experience, and especially I found tech to be very beautiful. In fact, I was very much attracted to this contents, table of contents, what do you call this? Contents page. It's so beautiful and organized. It looks wonderful. And the default font also, so that was what first attracted me, you can say. And I found especially mathematical typesetting to be very easy. Just write a code and just write few lines or few letters and you have it on the screen. Just imagine using a word processor or a GUI program for doing this. It's so tough, actually. And we had a lot of math-intensive, you can say, courses during our master's program. And eventually, when I worked as a university lecturer, I was handling the courses linear algebra and electromagnetics, which also are quite math-intensive. So I really like the way that LaTeX is so easy to typeset math, especially. And of course, there are other benefits, like you have the list of tables, list of figures, automatic indexing, and we don't have to bother anything. It's all pre-built, and it's very nice. And one more thing which of late I am feeling the benefits is the separation of form and content, which I am going to explain in some time. And finally, the most important point which I want to emphasize, that there are this community of volunteers who are actually helping people like me. I am just a beginner in this software. I am really grateful to the community of volunteers, especially when we were publishing a book. In our ashram, I am the only one who uses LaTeX, so I could not ask anyone, nor do I know anyone to ask. So I just went to these Stack Exchange or Overleaf and just asked my question with a minimal working example, and then they give the answer within a day or two. And I have been benefited by that a lot, especially when the publication was nearing its date. We had to give a proofreader's copy to the other team members. So at that time, I did not know how to do such a big book. It's almost 230 pages, so in size. So at that time, Andrew Stacy, who is the author of the PDF pages package, he just gave me a code and I ran the code. It worked, and I could immediately print it out and give it to the proofreaders. So similarly, other people like Sam Carter and others, they also helped me a lot when we faced a lot of challenges while doing this processing. So how this volunteer spirit is very important, because there is no exchange of money involved. It is just a desire to help others. That's all. I myself am a full-time volunteer, and we don't work for money. We just want to help people in whatever way we can. So I really appreciate this volunteer spirit, which is actually fueling the whole tech community in one sense. So that's a very wonderful thing. And now I would like to explain how we use LaTeX in our ashram. So the first thing is we have these recitation books. It has the verses from the Bhagavad Gita, a sacred scripture in India, and we have this multilingual approach wherein we have used the Devanagari script along with the Kannada script and the Devanagari script along with the Roman script while we publish the books, because many people cannot read the Devanagari script directly. For them, the Roman script and the local language, it helps a lot. So these are the 3 books which we have published, and some copies are on my table also. Please feel free to just have a look at them whenever you have some time. So I would like to just explain some key features, how I got it done through LaTeX. First of all, this chapter title, we have it on a new page. It's not along with the other content of the book. It stands out when it is put on a new page. So I use this package, fancy chapter, and with some fiddling around, I could get this kind of appearance. And then to convert the Roman script to Devanagari, because as some of the Indians might know, that if we have to type in the Devanagari script, it is quite difficult, because you have to learn the keyboard layout, and then we have to memorize so many things, and it can be difficult in a multilingual book. So I found this very nice a piece of software which was there in the GitHub. Earlier, I think this person who has made this software, his name is Dominic, if I remember right, and he had also presented in one of the TUG conferences in 2011 or so, when it happened in the River Valley Technologies campus, isn't it? Yeah. So I just had a chance to watch his video, and I used this software, and it's really wonderful. I just had to make a small changes here and there in the original script which he has given, and then it perfectly fit our needs. So this is the way we got the Devanagari. We generated the Devanagari from the Roman script, and then we had to do one more thing, that we had to number all the verses. There are totally 700 verses spread over 18 chapters. So I was not very sure how to, of course I knew how to create a counter and make the counter to work and all that, but then we have to do it, we have to reset the counter at the end of the chapter, and then use a new counter or a new, enumeration at the beginning of each chapter. So I thought, why not to use some existing counter which can do the job. So then the idea struck. This I got it actually from Luke Smith. Luke Smith, who writes about tech. So he had mentioned about this package called TitleSec, and wherein we can actually specify how the section numbers and the section title look like in the final output. So I'll just show it in a second how it actually looks like on the screen. The title format command, beginning from the renew command. So the renew command makes sure that the section number is in the Arabic numerals, and then the title format command makes sure that the section is printed on the right side of the page. And then we have a formatting for the section number, and then the separation between the number and the content, and then finally how much distance or any additional texts, if it has to be there, between the section number and the section title. These things can be mentioned here. Of course, the second argument and the fourth argument, it's blank, because there was no need for that. And you can see that the section number, we wanted to look big, so that at a first glance you can just understand where you are in the chapter. So how I implemented that while bringing it to the verses. The first thing is I defined a new command called, these are all just different names to specify different font sizes, because we wanted to make maximum use of the available space. And it's a very small book, as you can see, so I had to sometimes little bit tweak the font sizes and give different font sizes for different verses based on how much space it occupies on the final page. Therefore, I just defined 3 different commands, both in the Devanagari script and the Roman script. And we don't want to have the numbers beside the Roman verses, because those who know the Devanagari script, it's more compact than the Roman script, which means it doesn't occupy a lot of space to convey the same information. And therefore, the section command was used for the Devanagari verses only, and the Roman verses were told not to display any section numbers. That is possible by the asterisks, which you can see. Yeah, this is just a sample page of the book. The usual stuff, I don't want to elaborate on them, the headers and all that everybody knows. We have this chapter title at the beginning. The first line is the Devanagari version. Below that is the Roman script. And then each verse, like this, it goes on throughout the book. First we have the Devanagari version, and then the verse number just at the end of the verse, and also the Roman number, the Arabic number at the margin, right margin. And in this way, we have the whole book made like this. Of course, we have to do a lot of proofreading because there is always a chance of some errors to creep in. And I was told very strictly that there should be no mistakes at all in this book. So around 6-7 people actually went through the whole book to make sure there are absolutely no mistakes. And finally, when the book was ready, we took it to the printer. And the printer said, you need to have the crop marks so that we understand where to cut the page. And then I just searched it on tech.stack exchange, and then I got this solution that just give some offset values, and then it takes care of. Basically, what we are doing here is we are defining a bigger page, and then our content fits inside that bigger page. And then you see the crop marks on all the 4 corners. So they give an indication to the printer, or to be more specific, to the person who cuts the pages after the printing is done. So he knows where to cut it. And then the final, it is sent for binding and other things. So it's quite a simple code. Just I had to figure out the exact sizes. It took some time. And then I had to actually measure it with a scale, how much it's wide and how much it is, tall, and then give some figures there. Fine. The next thing which we have done is about the weekly planner. Weekly planner has the Gregorian date printed along the columns, 7 columns, and then it has the Vedic date. It also has the Vedic month, and then any event which has happened on that date. So these are the things which I had to incorporate, and I had also indicate whether it is a full moon day or a no moon day. These things are very integral part of the Vedic calendar. In Devanagari, in Sanskrit, we say Amavasya and Purnima. Those who are Indians, you might recollect these names. So these things were given to me as a task. So I thought, let me use LaTeX for that. So this is the raw data. We have a software which is actually a astrological software. It can generate, if you give a time frame, from and to, then it can generate all these things which I just now mentioned. What is the Gregorian date? What is the day of the week? What is the Vedic date? And then we have the waxing and the waning phase of the moon. In Devanagari, in Sanskrit, we say it as Krishna Paksha and Sukla Paksha. And then we have the Yoga and Karana. So these things will be automatically generated by that software, and this is what we got from that. So initially I used to copy paste and do it the long way, and it was quite time consuming, and I asked myself how long how long you want to be just a beginner. You have to use tech in a nice way. So then I felt that it is better to create new commands which will take these data as input and then format the way I want it to display. I want it on the page. So therefore, I just use some simple, find and replace sequences to cut off all the white spaces and use bring everything in terms of arguments which can be fed to the command. So this is these are the commands which I have defined. The first command looks for the Gregorian day. You can see at the top here. You can see at the top here that it mentions that day 1 is an argument which is given to this command dd1, which will actually interpret this as the Gregorian day. And then the second command talks about the whether it is a full moon or a no moon. And the third command takes the input of what is actually the Vedic day of that. In Sanskrit we call it as tithi. And then the fourth command takes the input that is there any event which happened on that day. In a similar way, all the 7 days, in a similar fashion, all the 7 days were first defined, and then how these data which has been taken as inputs, how do they display? Okay, this is one sample code. Now, how actually it looks like at the end, with all the events, the full moon day, no moon day, the Vedic date, the Gregorian date, and everything which is there. So finally, how it looks like in the final output is being determined by this code. So I say Shukla and Krishna, which means the moon is now on the waxing phase, and within a week it is transitioning from waxing phase to the waning phase. That's called Shukla and Krishna. So if we come across such a week, then such an argument, such a command will take 4 arguments. What are the arguments? Number 1 is which is the month which precedes the full moon day. According to the Vedic calendar, the month changes at the end of a full moon, which means when we have a full moon day, that will be the last day of that month. And then the next phase of the moon, it marks the beginning of the next month. So that's how it works. So the first argument takes, it determines what is the month which was there prior to the full moon day. And then the second argument says here, how many days in that particular week we have that month existing prior to the full moon day. The third argument says, what is the name of the month which is going to come next. And then the fourth argument says, how many days in that week will that month exist in that week. Obviously, the second argument and the fourth argument, if you add them together, it should add up to how much? How much? 7. Because there are only 7 days in a week, right? Like that. So you see the last line here. So I say the first month is Pausha, that is there just for 1 day, and then the second month is Magha, which is there for 6 days. Totally there will be 7 days. And then the days, how they should look like, and then what are the events which are on that day. And then we finish the page. This is how the whole thing works. The same thing has been implemented for other combinations. There are 4 possible combinations. First, you start with the waxing phase of the moon and end with the ending phase of the moon, waning phase of the moon. Start with the waning phase of the moon and the week ends with the waxing phase, or throughout the week there is only the waxing phase of the moon, and throughout the week there is only the waning phase of the moon. These are the 4 combinations that is possible. So I just wrote 4 different commands for each of them, and very similar to what you are seeing on screen. And then this is the output of that, whatever code was written. So it mentions the Gregorian date, it mentions whether it is a full moon day, this white circle, and then it says the Vedic date in Devanagari script. It says the event which happened on that day, and then it also says what was the month on that particular day, the Vedic month, of course. So in this way, the whole calendar was designed. And then the next task I had was to make a lecture schedule. So obviously a lecture schedule also has all these information, but it has to be printed in a vertical format. It should be fit in 1 page. So again I thought, rather than, of course I did again do the wrong way or the long way, copy paste everything and put it in a table and all that. Then I thought, we should use the capability of LaTeX, especially that of separating the form and the content. So what I did was, so I am just giving both of them side by side just to show the comparison. here we have the 4 commands which was already there, and I just add 2 more commands because this is a lecture schedule, which means throughout the month different people will be speaking and they will have different topics to speak on. So who is the speaker is the fifth argument, and the 6th argument on what he will speak. I just had to add this. And with respect to formatting this information, whatever is there, so as you can see here, all this is a horizontal format where all the dates, the days are spread over a week. Rather here we have a vertical format where we need all the days to be printed in a vertical fashion. So I just did some changes there. This shows the actual data, how it looks like, a small comparison between both. And finally, this is the result. So I didn't do much work actually. I just had to add 2 arguments and I have to feed in data into those 2 arguments, and that's the end of it. And it made my work very easy. I could save a lot of time. So this is how we used LaTeX in our ashram. So this actually brings me to the end of this talk, and I also wanted to mention some things related to my future plans, but I will mention it in the tugboat article which I am writing. And just some few closing thoughts that I feel so that this system or this community of tech users, especially in India, we need to have it on a more grassroots level, especially because India is similar to Europe in many ways. We are also multilingual. You cross the boundary and the language changes. So we have to empower groups which can penetrate at a more fundamental level, especially the student community, so that people are aware that there is something like this existing. Otherwise, we don't come to know at all, that we have LaTeX. There is not much awareness actually, and just like Eric mentioned, that he showed the whole world map, and India was in light green color, by which I understand that we have a lot of mirrors, CTAN mirrors in our country. So I just feel, the TUG tech user group at the national level, they have to try to break up into state level user groups and try to see ways and means how we can spread the awareness of LaTeX. Just imagine if I had to do all this in a graphical user interface. We cannot do anything. There is nothing called as portability of the code. It is fixed with that particular software or the package, whatever it is. And it's not multi-OS, and we cannot, to have the multilingual also, it's challenging. And the indexing and the table of contents and so many other things. And we cannot include figures in that, which is possible in LaTeX by means of ticks. We can program the figures, we can define circles, rectangles and all that. So I felt that using LaTeX was a no-brainer actually. It was my first choice for publishing books and all the other things which we have done. I am appealing to the user community that we should have more awareness spreading programs in India, especially at the student level when they maybe come into college or so, and it's possible. It just requires some activism, and it can be done. So that is the end of my talk. I would like to thank all of you. In whichever language you prefer to read this, it has the same meaning. Any questions or comments or corrections? You might have found some rough edges in the code, but I'm just a beginner, so I think it's okay.
Maybe any questions online, brothers?
Thank you. I don't see questions online, but I would like to maybe comment, maybe a suggestion. Unfortunately, ZTAG is less and less maintained nowadays, so I wonder whether you consider moving to Lua LaTeX because it's actually maintained and debugged and so on. So what are your plans?
Okay. So that my question to you is the transition easy or difficult? Okay. Because I have very less time, that's why. Okay, but I will consider your point. I will.
It's not difficult, but you may want to think about it because it will probably a long-term solution.
Okay. Thank you, Boris.
Yeah, the transition, I also use a lot of packages you've used and but also a lot of music related stuff. Eventually, there was a point Lua LaTeX didn't support something, but I just wrote a patch then. So you should ask help for if it's not working in Lua LaTeX, because I think we can manage the same thing with that engine.
Yeah, thank you. Yes, Salim.
Okay. Did you come across anything, any mythological or religious stuff for which there was no support from LaTeX?
Till now, this is what I have done till now. But I have some plans how LaTeX can be used to represent the information given in the Vedic scriptures. Especially the programmable ability of LaTeX. If you know the Vedic scriptures, they are highly systemized. Systemized means everything is in a particular format, and generally, even to convey a point, there is a particular steps which are used to convey a point. So these things can actually be programmed, and even if you consider the way time is represented, it's cyclic, it's not linear. That is first. And if you see our architecture, it is highly symmetric. So these things I feel are very favorable for a programming language. It can be codified. And what challenges will come, that we have to wait and watch. As of now, I don't know, but I really have these thoughts in mind.
I just have a small suggestion and comment. In your talk, you mentioned that inputting in Indian languages is kind of difficult, but I would disagree, and there are good layouts, and basically with some training, and especially because you mentioned you need to type in multiple languages that are there in India, I would say that there are standard layouts, ISO standard layouts by Government of India, and they require a little bit of training, but once you get a good hand over it, they are extensible to all the Indian scripts, and this is the Unicode age already, and we should not rely on conversion programs which rely on other scripts to type or to get text in our scripts. So in order to be more modern and more rich in the input, more and more users should type in Unicode. So that's just a suggestion you may consider.
Yes.
So yeah, I really don't think when you have a lot of work to do, it's actually easy if you do it in your script and not the other way around. That's just my personal comment.
Yeah.
Thank you.
Yeah. If I can just clarify a point, that actually what happened was we had all the verses in the Roman script to begin with. And frankly, as I had mentioned to even Boris, that there is very less time in our daily life to do this kind of stuff, because we have a very tight schedule. So I had to rely. That's why I did that. That is just a reasoning which I am giving why I did. But I agree with your point. I got this suggestion from another gentleman also. And when we are dealing with prose, then we have to type in the. It makes sense more to type in the actual language, because we already had the Roman script available. So it took very less time to, convert it and slightly modify it. As you know, when the consonant is followed by a vowel, then we cannot have they should come together, isn't it? In the Devanagari script, it's like that.
Yeah, I get your point, and especially when you have some data already in one format, it's difficult to convert and all. But I just wanted to convey my disagreement that typing in Indian languages is not at all difficult, and especially when you have good layouts, government-supported layouts.
Yes.
So I just wanted to clear that.
Yeah. I'm actually working on Tamil books also, and I type in Tamil layout, so that makes sense.
Just want to add to that point.
Yeah.
In Indic languages, you can have two kinds of keyboards. One is InScript, where you have to really learn the layout, which is the keyboard layout. The other is transliteration.
Phonetic.
So you could phonetic transliteration. So you could actually type in Romanized characters.
Yeah.
But the input will really be Unicode.
Yes.
I can't type myself in InScript. I always rely on transliteration.
Yeah.
But I always type in Unicode.
Yes. I'm aware of that. Thank you. Yeah.
Sir, I am a typeface developer, and I have developed a Vedic Sanskrit many in the all Indian script.
Oh.
So I have seen your books. So I have found some little problem with the leading. So how can maintain the leading from the LaTeX? You can see the page number O.
Yeah. Can you come again? I could not understand your point.
This is the text leading. Text leading, line of gap.
The line gap.
Line gap.
Line spacing.
Okay, line spacing, yeah.
Whether it could be adjusted from LaTeX. So I could even answer that question. Yes, it's very easy.
Oh, I have found the many slokas. The leading is not same.
The line spacing between the lines is not the same.
Yeah.
That's what you mean to say?
Yeah.
Yes.
This is the page number O and other.
It is true. I know that. I have observed that. It is true.
Any other questions? Okay.
Okay.
Thank you. So our next talk will be given by Jean-Michel Hufflin. He lives and works in the east of France. His presentation is about teaching LaTeX to different audiences. Bonne chance.
Okay, all right. Okay. So, many of you know me. I'm an assistant professor in computer science. I'm not a young man. I will be retired in 1 or 2 years. So, in fact, the idea was to sum up my experience about teaching LaTeX. So, I will explain that. Some particular points for computer science students, other students, how I evaluated students when that was relevant. So, in fact, all my classes about LaTeX were practical. That is, there were lab class, possibly after lectures with demonstrations. In fact, the first class was in Faculty of Letters for students of digital edition. This diploma no longer exists in my university. That was in around 26. Other classes are in Faculty of Science. Our computer science students still in use, for mathematical students and physics and chemistry students. In fact, for the students, that depends. That is a special section with a special enhancement in some additional topics. Depending of numbers, they are grouped for LaTeX classes or separated. For example, 2 years ago, they were separated because they were 20 plus 15. This year, in finishing, this year there were 28 students in one group. So, in addition, but that was quite informal, I helped students for writing medical thesis, and at the end of a nurse school for final dissertation. And what I mean by what I was asked, that is, I was quite free to put myself the program. But at each time, I have a precise requirement on some point I have to emphasize. So, for example, for students in science, prepare them to write document by several people. That is, some parts written by different students and assembling the whole in a second step. For example, in Faculty of Letters, I had to emphasize multilingual aspect. That is, encoding commands for a Bible package. At this time, the polyglossia was unknown. Of course, I was asked to introduce the math mode for math students and physics science students. And special attention to bibliography management for digital edition and physics, because the students were asked to manage an important bibliography. That is, not only show them how to use BibTeX, BibLaTeX, and others, but how to manage important references, for example, with JabRef. So, about bibliography, maybe you think that in France, things are standardized. No. Look there. For most scientific documents, the bibliography is sorted alphabetically. References may be labeled by numbers or alphabetic keys, but the bibliography itself is alphabetically sorted. But that's not true for PhD in medicine. The order needed is the order of first citation in a document. In fact, many people are militating for this convention to be changed because that's nonsense. If you change your text, this change can induce the order in the bibliography. So, in fact, alphabetically sorted for most scientific documents, most scientific, that is mathematics, chemistry, computer science, biology, physiology. But for physics, the bibliography are given as footnote in the chapters. If you are in physics, that is, there are both footnote and the global bibliography. If you consider nurse dissertation, no global bibliography, just footnote on the fly. So, that is for a bibliography that is specific to a particular public. What about implementation? In France, Bible and bibliotech are very deeply used in letter and human sciences. For example, psychology, philosophy, okay. What about science? The problem is not refusing bibliotech, but in some most conferences, there is still automatic tools with BibTeX. That is, when you submit, you put a text file, a bib file, and automatically PDF LaTeX and bibliotech were run. It is impossible to use Bible. So, for tools too, that is specific to some public. Well, and I adapt for some specialized packages, for example, for physics and chemistry, and for recent classes, I also talk about the Beamer package. So, in fact, my classes was in one shot, started from scratch, except for this year, that is terminating. Because, in fact, in France, every 4 or 5 years, there is a reorganization of teaching units monitored by the state. So, in fact, last year, this reorganization moved my unit from the first year to the second. So, this year I had students I already know, and I didn't want them to attend the same courses. So, it was advanced feature this year for computer science students. So, what I noticed, generally for any kind of public, asking students for typing new text is not a good technique, because as here, they will have to type long text, and long text by length and time spent to first version, second version, and so on. In fact, if you begin from scratch, you can ask students type a document class, use package, but many will do some typing mistakes. You will spend a considerable amount of time, and that will be very, very counterproductive. No, the best technique is to provide them a middle-sized text. For example, some section, and they can compile it, then can using some variants, for example, 1 colon, 2 colon, changing the size of character, but at the beginning, the best technique is to emphasize this possibility of changing because of a new requirement, because of new version, or what other problem. So, for example, maybe you will add an index for person name. Maybe not. So the best technique is to use a command for person name and rewrite this command at each time. Or, for example, some category of words that will be typeset using some effects. Italicized characters or boldface font. So, in fact, even also that is something subject to change. Early, also I introduce cross-references, commands label and ref. The advantage to start from a quite long text, that it's quite easy to add a small section, so some numbering of section changes, and students can observe that. So, about computer science students. In France, they practice languages like Java or C++. Okay? That is, they are used to modern techniques. That is, lexical analysis and syntactic analysis. If you are not familiar with programming language, that's analogous to separating a text into successive words, that is lexical analysis, and checking that a sentence is correctly built from a grammar point of view. But in fact, that are modern techniques. That was not always the case. For example, in tech, there is no lexical and syntactic analysis. analyzer is just encompassed. As another example, if expressions in TUG are processed dynamically, that's very different to what is done presently for modern languages. For modern languages, that is, a kind of tree is pictured when the text is analyzed. From my point of view, that may be interesting for computer science to see this difference. And another very deep difference. That is very static. That is, you don't have dynamic allocation. If you are not familiar with this notion, that means the resources we use for the memory are finite and not extensible. Using dynamic allocation is very, very common for modern languages. Here also, there is a rich comparison with TUG technique and nowadays techniques. And in fact, as students can see, TUG is a very efficient program, but let us be honest, that's a kind of legacy program, because no one has to change it. That's the truth. So, in fact, in some units, students are required to write good programs. But for them, writing good programs is writing like the teacher. That's quite imprecise. But showing them a legacy program is very, very a good thing for them. So, hooks could have been put as another example, communication with another language or two. That's also a good thing for them because given the curriculum that is in first year or second one, that is the first time for the students to meet a couple of languages, that is Lua and TUG. The year after, they will learn Ruby plus Java. But at this time, it's the first meeting with completing languages. That is, and why? That is programming jobs for Lua and typesetting job for TUG. So, in fact, I also introduced them to the graphic package and its advanced option and tickets. I spent some hours this year, and for non-computer science students, pictures are given, but for electrical circuits for physics students. For all students, last year, I introduced a package allowing processing of Excel file. That is interesting, for example, if they have to, for example, for an activity report. So, for example, or for measurement result. Let us not forget that for physics of chemistry students, many data are the result of experiment and the specific entered as Excel file. So, that depends. Some units were free, not really need for an examination, and some I had to organize a classical examination. Sometimes that was a lab class with a document to reproduce for beginners. This year for advanced students, that is computer science for the second year consecutively, I give them a mini project. I will translate this mini project in the complete article for TUG 2025. In fact, that is collaborative work about an imaginary company selling physics formulas. So some students have to typeset many complicated formulas in physics. Another group has to process accounts, that is for the imaginary society, give them as tabular and in pictures with stickers, that is a diagram with cheese. And the third group had to process the list of employees and give the average age of employees. In fact, the list were students themselves, admin, in order for the average ages to increase. And in fact, they have one mini project. That is, the third part had to be assembled and processed. That was funny. I was told that students very, very enjoy this project. That will be one shot because next year I will have second year, but beginners. So, in fact, from my point of view, if you teach LaTeX, that is something quite philosophical. That is showing how to process to be subject to change. Avoiding information redundancy, for example, by defining new commands. For example, package interfacing Excel go in this direction. That is, you don't have to build a text version of Excel as if it was the case many, many years ago. And getting high quality output text. What's this question mark? No, in fact, I think that's relative. When I was a student, that was at the beginning of the 80s. Books were typeset nicely. That was the time of the first edition of Donald Knuth's book that was butchered. And in fact, when the teachers gave us some documents, they were roughly typeset with typewriter. Now, modern students don't know this situation. They are given by me and other teachers documents with PDF clearly processed with LaTeX. So, somewhat they get used to high quality output text. And now, if you consider document, you have documents which not very high quality, but not very low either. That is, I think the average quality has increased. So, in addition, if you consider LaTeX, many years ago, 20 years ago, or even 30 years ago, some knowledge in typography were required in order to get something correct. But it's not always the case now. If you write in French, in German, about Hindi, I don't know. But in some languages, package like Bible, Polyglossia, and some improvement of packages, you can get high quality text. But the challenge is to get maintainable text. If you have questions.
Any questions for Jean-Michel?
Thank you for the session. I got some pointers from your session which I can implement at our own ashram. I'm forming a team of students and teaching them. I'm forming a team of students and teaching them LaTeX actually. So I got some good inputs from your session. Thank you.
Hi, Jean-Michel. Thank you for the talk. Do you have any insight on how the students then really use it after you gave your lecture? So, do you have converts in your group?
Oh, there was a question, right? Yeah. Oh, can you repeat the question once again?
Oh, so my question was, are the students sufficiently converted after yours to keep using LaTeX? Do you test that in any way, or that they abandon it again?
Yes, I think that is the best. Students get used to best LaTeX. For example, I was often asked for advice about CV resume. So I can think that students were attracted by LaTeX.
Yes, Bert?
Well, I just want to comment that I really like the idea of mini projects at the end of the courses. And just a personal anecdote, some of my students had really good knowledge of LaTeX. I asked why, and they answered, well, our previous professor wanted us to write for him the course notes, and after some work with him, we were really proficient. So anything which they do not as a anything real that they do, anything big project is probably the best way to teach them practical knowledge.
There was no question, right? Okay.
In fact, I think the project is very accurate for that. And even there is a graded lab class that is like a project since they can get access to internet. That is, I teach students to use LaTeX, but also to use its documentation.
Thank you. Okay, that was the talk. We are going to lunch now. Thank you, Jean-Michel.
There are a few announcements. So 12:20 is lunch. So from 12:20 to we'll be back starting the next session at 13:50. But before we start the next session, we'll have a photo which will be on the near the pool. That's where the photo session will be held. So everybody is welcome to join over there for the photo session. It will start exactly at 13:30. Once the photo session is completed, we'll assemble back over here and the session will start. In addition to that, the people who are going for the bus ride in the evening need to register their names with Bindu. She's at the back. So just please register your names with her so that she gets the exact count of people who are coming for the bus ride in the evening. So it's a free of cost event. Anybody is free to join for the bus ride. Okay, thank you. So the photo session is near the pool at 13:30.
Which floor?
When you get into the lift, it has a button which says pool. I'm not sure about which floor it is. I suppose it's P, capital P. Capital P is the floor.
Yeah, that's okay. I check this one. Yeah, I don't need this one. Yes. Thank you. Thank you very much. Okay. What's the problem? No, it's off. is not going very well, is it? Maybe I should use this one. Huh? Yeah, okay. Because I don't... Okay, good. Perfect. Yeah, because online, of course. Yeah, I know. I survive. You solved the problem, Ulrike? Good. Going into sky. It's very relaxing. It tells me if I talk too long, because then it goes like this. 2.
Hello? Hello? Hello?
1, 2, 3.
Hello?
Hello everyone, welcome back. We'll continue with the talks. So the next talk will be by Frank Nicola, who has been leading the LaTeX 3 project for the last 30 years. So he'll be talking about accessibility in PDF. So over to you.
Thank you. I hope you had a good lunch. You're relaxed and a little bit sleepy, because this is what you need if you want to get through my talk. So I'm going to talk about accessibility of PDF documents and how accessible they are and how accessible they should be. And as a short motivation, PDFs in the STEM world are very important. There are many reasons. I only give 2 here. They produce a final format which is rendering formulas and everything very precisely to what the author has intended to convey that information. There are many others. One not unimportant one is that large part of the STEM world is using LaTeX to produce PDFs and to produce documents, and LaTeX is producing PDF documents. So PDF in the STEM world is actually quite one of the main formats. Now, perception of PDF, accessibility, if you ask around in the accessibility community, if you talk to people who are blind or have other needs in that space, then basically what you get as a feedback is PDF is totally rubbish. We can't use PDF documents to understand what the contents of the document should be if we are in need of accessibility tools. And so one thing that we did recently was to make a reality check and see how good or bad things are in case you need accessibility. So, in other words, what have we been inflicting to those users for the last 30 years since we are producing PDF documents as the output of STEM? So, what we did was we produced, artificial but hopefully typical STEM document and check out what that means if it comes to accessibility. And at the end, there will be some conclusions. So this is the document that I'm going to talk about in this presentation. It has a typical preamble, a couple of packages being loaded. There's an abstract, there's a table of contents, you have a couple of headings, section headings, you have text, of course. We also put in a footnote, which sometimes happen in such documents. Then what we have as well is we have a bit of mathematics, not very complicated, but a couple of things here. We have lists nested. We have references to lists. We have figures and tables. There is an inline figure there at the right-hand side. We have a small little table with 2 columns and a header, or 2 headers actually. What else? We have a side note somewhere in the margin. We have a floating figure. We have one theorem and a bit of verbatim data. And finally, we have a bibliography with some citations somewhere. So that's the document. And I think you you will agree with me, it's kind of what you typically find in such documents. The complexity is not very high, so it shouldn't be too difficult to read this aloud by some accessibility tools, right? So what we did, we processed it with LaTeX. We used screen reader for PDF, Foxit in that case. We used NVDA for speech generation under Windows, and we used an NVDA add-on to have the mathematics being read. That's sort of the tool set we used. And did you memorize the structure? Bit? Okay. In that case, close your eyes, relax, enjoy, and I will read it to you. Or rather, I'll have it read to you, okay? And I would suggest you actually don't peek. You already seen the source, so you have an idea of what is in there. You will see the document as it is rendered on the screen, so if you really need to peek to get an idea of what is read to you, do it, but try to do without. Okay? No, I show you. Here's the document, but as I said, close your eyes. Okay.
Layout is used. The tagging enables the reading order to correct.
It was not from the
Column
beginning.
example. The LaTeX Team 2025-0618. Abstract. An example document showing automatic tagging of typical structures found in a LaTeX document, including titles, sections, theorems, lists, citation lists, and mathematics. A two-column layout is used. The tagging enables the reading order to correctly follow the flow of text through the columns. Contents. Link 1 Introduction 1 Introduction 1. Link 2 Document Structures 2 Document Structures 1. Link 2.1 Mathematics 2.1 Mathematics ... 1. Link 2.2 Lists 2.2 Lists ... 1. Link 2.3 Figures and Tables 2.3 Figures and Tables ... 2. Link 2.4 Theorems 2.4 Theorems ... 2. Link 2.5 Verbatim 2.5 Verbatim ... 2. Link 3 Citations 3 Citations 2. 1 Introduction. This document shows a typical two-column document incorporating tables, figures, and mathematics. Apart from two commands at the start to enable tagging, and a small amount of additional markup to give alternative texts for graphics inclusion, and link to specify the heading rows of tables. 1 The docu. 1 The current tagging markup for tables is temporary and a new interface for tagging tables will be developed. Ment just uses standard LaTeX markup that would be used in any LaTeX document since the 1980s. List with 1 item 2 document structures 2 document structures out of list. 2. 1 Mathematics. Let P be a prime, then NP equals N mod P. An aligned set of equations. F, x, equals sin x plus cos x f prime, x, equals cos x minus sin x. 2.1. Table with 1 row and 3 columns. Row 1 column 1 g, x, equals 2 cos xg, matrices. Column 2 xg prime, x, equals minus 2 sin x. Column 3, 2.2, out of table. 3412, 0111, equals, 3713, 2. 2 lists. Lists often occur in documents. List with 2 items bullet. They may be unordered bullet lists. Bullet or may be numbered lists. List with 2 items 1. Lists may also be nested in an outer list. 2 items within such a list may be refer items within such a list may be refer inst. Out of list, out of list. Link here we reference item 2. Table with 2 rows and 2 columns, row 1, column 1, page 2, column 2, row 2, column 1, column 2 out of table. A. Figure 1, larger image set as a float. List with 1 item 2. 3 figures and tables 2. 3 figures and tables out of list. Small images may be shown inline and small tables may be shown within the paragraph. Example name value. Table with 7 rows and 1 column, row 1, column 1, column 2 this 11, column 3 this 11, row 2, column 1, column 2 that 2, column 3 that 2, row 3, column 1 are usually placed marginal. Column 2 larger figures such as figure link 1 are usually placed marginal. Row 4, column 1 notes are in a float to be positioned at a suitable place to help. Row 5 usually placed in the outer margin. Column 2 with column and page breaking. Row 6, column 1, column 2, row 7, column 1, 2. 4 theorems out of table. Theorem 1, Fermat's last theorem. If n greater 2, then there are no non-zero integers a, b, c such that n plus bn equals cn. 2. 5 verbatim. Some documents require verbatim code blocks to be displayed. Main, printf, hello, world. 3 citations. It is also possible to cite works from a BibTeX database. Here we cite database. Here we cite link database. Here we cite 2 and link and 1 from the tugboat.bib sample file distributed with BibTeX. References: 1 Taco Hochwater, LaTeX, Tugboat, 28, 3, 312 313, 2007. 2 Don Knuth. Comments on quality in publishing. Tugboat, 5, 1, 6767, May 1984.
Okay, so the next question to you is, you have this pen and paper, write down what you understood in the article. I fear it is not much, is it? Come on, go back. Okay. So, I hope you had an enjoyable readout to you. What's your verdict? Here's mine. There are, at the beginning, a few words where you think, oh, this is okay, what's the problem? But then the rest was basically not in any way usable for somebody who has the need to do this. I've put down all these kind of things, and actually the presentation will be online after the talk if you want to reread it. I didn't put it online beforehand because I didn't want to have people sort of look through what I'm going to say. So here is probably not a comprehensive list of things that went wrong, like the footnote being read out to you in the middle of the word document, just because document was split over 2 columns. So it said docu, and then the footnote was read, and then meant was the next, and stuff like that. You have the mass ICS, and you have a lot of things. The dots are more funny, but I can tell you, I listened to these kind of things 100 times, and after a while, the ... really gets you. So there's a lot. Mathematics are completely non-understandable because only ASCII characters, letters basically, are read. Everything else is gone. Spacing, meaning is totally screwed. I don't know if you noticed the matrix was read out in a totally strange order. I have no idea how it came about, but it was backwards and sometimes from one matrix to the next. Very strange. Yeah, it goes on like that. I have 4 pages and I'm not going to list them all to you. But basically, the last one was also very nice, where you had database and sometimes links were repeated several times. You heard the same half sentence being read to you twice without any idea why. So this is the art of the state of the art that we actually do in what we force people who have the need for accessibility to listen to or try to work with. And so we tried a couple of different variants of this, like using different previewers. The processor, the process then was in some cases, in some combinations, slightly better in places, but then in other cases it was even worse. Just a quick one to you here. It's in the introduction, the text.
2.1 Introduction. This document shows a typical two-column document incorporating tables, figures, and mathematics. A partir from MTWO command SATTHE star TTO enable e-tagging, and DA small L amount TOF addiona L markup PTO give e alternative e text SFOR graphic S inclusion, and DTO specify THE head and G row.
Okay. You notice what happened? At some point, it suddenly started to read out character by character. I don't know why, but it has to do with the fact that there's a link in the paragraph, and somehow it got totally confused. I can't tell you why, but I mean, this is the kind of things we do. We have done for the last 30 years. So, conclusion, it's actually evil. And heuristics that are applied to an untagged PDF only work if the document has essentially no structure. Even a single footnote is breaking the things apart. The heuristics don't do it on the ordinary reader software. So the question is, what could be done better? So we tried a couple of other experiments. We said, okay, this is the free reader. Let's try the professional version that say to you, we auto-tag your document. So it has proper document structure, which would mean that if you go to a PDF checker, it would give you a check mark. The document is fine. This is what we did. The results were, unfortunately, essentially the same. Some things were better, quite a lot, so more structure was recognized, but the problem is the heuristics go from the visual appearance, and certain visual appearance are similar for meaning different things. And so the heuristics always have to make a choice. What could this mean if there is an extra space? Is this something separated, or is this just an ordinary word space? So a lot of those things go wrong. We have, for example, it was interesting that there are differences in the program, both from Acrobat Pro when it was done with Mac OS and when it was done with with Windows. So we have basically, I'm not going to show those all. So for example, in Mac OS, the table was no longer reading out the dots, big improvement actually, to my ears, but it was the last line, which was section 3, was suddenly announced as being a list. I don't know why. It was a list with one item. Footnote, again, was not recognized in case of the Windows version, surprisingly, because it was recognized in case of the Mac OS version. And in all cases that we tried, the mathematics stayed the same. So we had things like this.
1 Mathematics. Let P be a prime, then NP equals N mod P in a line set of equations, F, X, equals sin X plus cos X F prime, X, equals cos X minus sin X, 2, 1, G, X, equals 2 cos X G prime, x equals minus 2 sin x, 2.2, matrices. 21.3, 14.11, equals 1. 3037, heading.
Okay, so it is better than the last one. The last one had a couple of tables introduced and mixed up the text with the formula. But still, I mean, given that half of the symbols are missing, you are not introducing something like a superscript or whatever. You are not introducing matrices. For a mathematician, this is not deducible what this formula should be, right? So, okay. As a summary, depending on the complexity, you get a little bit further, but basically, as I said, we have this problem that auto-tagging relies on heuristics. They are a little bit more sophisticated than for the free readers, but effectively the document, if it is a STEM document, is still unusable. We have mathematics and graphics. Graphics were also failing. They were simply dropped. So the inline graphic was no longer there, even though it has an alternate text or something in theory, or should have. Anyway, that's not the way to get better. Auto-tagging for STEM documents is not possible. I mean, it gives you the check mark, so your university or whoever is requesting that you make accessible PDFs will give you that, but the content is not presented in any way that it can be used by somebody who needs it. So we made a couple more experiments. We tried and used the hype that is currently around and said, what can LMMs do here? So we took the document, the PDF, and asked an LLM. In that case, the first experiment was with ChatGPT 3, 5, or whatever. Please show full markdown source for an accessible document suitable for blind reader extracted from this PDF. That was the request. And the result was not bad. It sounded quite good, but the problem was, first of all, every time in the nature of LMMs, you got something different if you were retrying it. There were rewrites, there were drops. So for example, the LMM decided that the footnote is not important. Notes were just gone out. And the footnote said something like, this is temporary syntax, it will change. Now this is quite an important information for that particular document. It was just gone. We then tried a lot of additional prompts, refining the prompts each time to try to make it do better. And it got better with a lot of experimentation of what to ask, but it never gave you anything that you could say, no, how should I say this? If I'm the author and I make this thing this way and compare it to my intention, I can decide that this is good or bad. But if I'm a user who needs an accessible access to this document, I cannot ask the LLM to do it for me because I cannot compare what is wrong. So effectively, there's no way with the LLMs at the current point in time to get a faithful content out, which is then accessible by the people who need it. So that's really, I mean, we have a lot of those things. In the end, graphics, for example, we couldn't make it do the graphics properly because it seems to not really want to handle that, regardless of the prompts we tried. There were, of course, heuristics applied in one way or the other by the LLM from its knowledge, understanding of the world. And sometimes it just misunderstood the structure as well. So those kind of things always stayed in. Yeah, as I said, it's not something that is in any way good as a workflow for a user who has accessibility needs. It's okay possibly for somebody who wants to produce an accessible document and can compare the result before giving it to somebody else, but not the other way around. So that's the conclusion here. And so what else can be done? Yeah, we can throw in the LaTeX source, this piece of top line, document metadata, language is English. We want to have a PDF version 2. We want to be according to the UA standard 2. We want to have archivable 4. F means that there are embedded files inside. And we want to have tagging. This is what you can put on top of this document. And we did this and then processed the document with Lua, LaTeX, and BibTeX, of course, because there was some references in there using BibTeX, as often as you have to do in LaTeX, so that our cross-references are resolved. And then the result on the Vera PDF tool for validation gave us this. Everything green. Now, as I said earlier, validation, unfortunately, Vera PDF is a very good validator because it understands PDF2 and so. But verification as such, unfortunately, doesn't mean a lot because the verification tools are pretty bad and they do not check anything concerning content and those kind of things. So that alone doesn't mean much. And given the time, I can now treat you to the full video. This is what we actually get now after this.
A 2-column example, the LaTeX team, June 18th, 2025. Heading Level 1 Abstract, an example document showing automatic tagging of typical structures found in a LaTeX document, including titles, sections, theorems, lists, citation lists, and mathematics. A 2-column layout is used. The tagging enables the reading order to correctly follow the flow of text through the columns. Heading Level 1 Contents, Link 1 Introduction 1. Link 2 Document Structures 1. Link 2.1 Mathematics 1. Link 2.2 Lists 1. Link 2.3 Figures and Tables 2. Link 2.4 Theorems 2. Link 2.5 Verbatim 2. Link 3 Citations 2. Heading Level 1 Introduction. This document shows a typical 2-column document incorporating tables, figures, and mathematics. Apart from 2 commands at the start to enable tagging, and a small amount of additional markup to give alternative texts for graphics inclusion, and to specify the heading rows of tables. Link 1. The current tagging markup for tables is temporary and a new interface for tagging tables will be developed. The document just uses standard LaTeX markup that would be used in any LaTeX document since the 1980s. Heading Level 1 2 Document Structures. Heading Level 2 2.1 Mathematics. Let P be a prime, then n to the pth power is equal to n mod p, an aligned set of equations. 2 lines. Line 1 with label 2.1. F of x is equal to sine of x plus cosine of x. F prime of x is equal to cosine of x minus sine of x. Line 2 with label 2.2. G of x is equal to 2 cosine of x. G prime of x is equal to negative 2 sine of x. Matrices. The 2 by 2 matrix. Row 1, 1, 2, row 2, 3, 4 times the 2 by 2 matrix. Row 1, 1, 1, row 2, 0, 1 is equal to the 2 by 2 matrix. Row 1, 1, 3, row 2, 3, 7. Heading level 2.2 lists. Lists often occur in documents. List with 2 items bullet. They may be unordered bullet lists, bullet, or may be numbered lists. List with 2 items 1. Lists may also be nested in an outer list. 2. Items within such a list may be referenced. Out of list, out of list. Here we reference item link 2. Heading level 2 page 2.3 figures and tables. Small images may be shown inline graphic small skull in a diamond, and small tables may be shown within the paragraph. Table with 4 rows and 2 columns. Row 1 column 1 through 2 example. Row 2 example column 1 name. Example column 2 value. Row 3 example name column 1 this. Example value column 2 11. Row 4 example name column 1 that. Example value column 2 2 out of table. Larger figures such as figure link 1 are usually placed in a float, to be positioned at a suitable place to help with column and page breaking. Marginal notes are usually placed in the outer margin. Heading level 2.4 theorems. Caption theorem 1. Fermat's last theorem. Out of caption. If n is greater than 2, then there are no non-zero integers a, b, c, such that a to the nth power plus b to the nth power is equal to c to the nth power. Heading level 2.5 verbatim. Some documents require verbatim code blocks to be displayed. New line, main open paren, close paren, open brace, new line, printf open paren, quotation mark, hello comma, world quotation mark, close paren, semicolon, new line, close brace, heading level 1-3 citations. It is also possible to cite works from a BibTeX database. Here we cite link 2. And link 1, from the Tugboat bib sample file distributed with BibTeX. Heading level 1 references, list with 2 items 1, Taco Hoke Water, LaTeX Tugboat, 28, 3312, 313, 2007. 2. Don Knuth. Comments on quality in publishing. Tugboat, 5, 167, 67. May 1984. Out of list. Caption figure 1. Larger image set as a float out of caption. Graphic example image A.
Okay, so this is what we got there. We gave this to Louis, who is Secretary of Science Engineering Division of National Board of the Blind, and asked him to take a look at the document and what he was thinking about being workable for him. This is what he came back with yesterday. So I changed my talk and put it on. And the conclusion I leave to you. Thanks for listening. There's a full set of those experiments and stuff on the web. And as I said, the slides will be online soon, the moment Carl Berry wakes up, and I gave it to him. Okay, that's it.
Are there any questions?
Many questions,
but loud, please. Close to the mouth.
I have many questions, but I can only do a few now. So
closer to the mic. I don't hear you.
Now you can. Yeah, this is the direction.
Yeah.
So the first question is, you have this math rendering, which so you have a LaTeX markup, right? So LaTeX markup is what you are trying to get at, or you guess it from the presentational aspect of it. So, for example, if you do not have the right LaTeX markup, and if you do it in some weird ways, using plain text or whatever, right? So what I'm trying to get at is, does the LaTeX give you clues? The LaTeX input is what you're trying to get at, or you get it from the way it is presented?
If you talk about mathematics largely, I guess we are using the LaTeX markup to generate tag PDF, the tags inside the PDF. For the mathematics, we generate MathML, but additionally, which is presentation MathML, but additionally we add hints to the MathML, which you can do, so that the reading is according to the intention. And the intention is covered by what kind of markup in the LaTeX source the user uses. So if he or she was using \apps for absolute value, the macro would help the generation of the MathML to actually make the MathML say absolute value. Certain things are by default. So, for example, you have heard things like to the power of n. That's essentially the way MathCAD, which is the interpretation software for the MathML, is interpreting something like a superscript in certain situations. If you want to have a different interpretation, different reading, then you would need to give an intent. And this is possible because we are based the conversion on the source macro. So basically the idea is that something like AMS Math is giving you a good reading by if the user uses AMS Math correctly. In other words, it is using the commands in the way they are meaningful and not just in the way that, how should I say, they would print on the page. I mean, you can build up any kind of complex formula by using PicTech and have little dots building your symbols, but then you don't convey meaning and nobody can deduce what it is. But the idea is that this is coming through the LaTeX source, and also if users in a special field have different interpretation that they want to convey, then we will offer, as part of macro definitions, the possibility to encode that in the macro definition. So you have to say that if your macro generating two vertical bars do not mean absolute value, but means something else, then you would give that information as part of the macro definition.
So in a way, the LaTeX input is your starting point.
Yeah, it's only LaTeX. The only thing that was done here was using the standard LaTeX I showed you before, the document, adding this one line on top. Actually, I showed it as 4 lines, but it's basically one macro with a couple of keywords. Adding this one line on top, running it, I think 3 times, or so, including the bib plus the BibTeX call, and the resulting PDF was read to you. No other software involved.
So in a way, you are trying to get at content MathML from presentational LaTeX. Because I saw that when 2 matrices are put in between to implied multiplication. Right?
The implied multiplication is a feature of MathCAD. They recognize that certain things typically do not have an explicit multiplication symbol. So if you have something like 2ab, you don't have 2 times a times b, you say 2ab in your source, and everybody in the mathematical world understand that this is meaning multiplication. Mathcat by itself decided that it would be helpful in case of matrices to actually spell out, because the matrix reads so long, to spell out that we are still in the multiplication situation. That's nothing that we actually did from the LaTeX source. That's actually Mathcat. We can enforce or suppress it, but that came not from our source. That's Mathcat. So, some more questions?
A couple questions from the chat, from online. Ross Moore asked why in the non-tagged example it started to read matrices from bottom to top.
That's a good question, and as I said in my talk, I have no clue. That's just what Acrobat as well as Foxit do. It must have to do with the fact that they are sitting sort of between the two lines, and I don't know what the heuristics are that decided on this reading order. It's extremely weird, but we haven't done anything to it, honestly.
Thank you, Frank.
Yeah.
Thank you. The time is kind of up. Perhaps we can take it offline.
Ulrike gives me the time to answer another question because she is expecting 10
fine.
minutes overdraw, so that's okay.
Do you have anything? The second thing was really very good. It even recognized, it did not say 2-column structure. It said 2-column structure. That was good. It recognized that there is a hyphen in between. So the text did not show the hyphen. That's intelligent. Do you have anything on subscript and superscript? Not as a demo, but do you know how it reads superscript and subscript?
In mathematics?
Yeah.
Or in mathematics, we had an example in the Fermat theorem. It was saying a to the power of n plus b to the power
That's power, not superscript and subscript.
Sorry?
Power is different. Superscript and subscript are different. That's mathematical.
If you mean x underscore I or whatever, x underscore.
Right.
I think it would say subscript, but this is again by default. A lot of the things we can delegate to Mathcat because we produce proper MathML, so the subscripts and everything is encoded as MathML. So we leave it most of the time to the reading software to interpret MathML correctly, and Mathcat is doing this very well. In case of this situation, it was saying to the power of, but if there is a reason why you have I'm pretty sure it says for the underscore 1 or whatever, it would say something like subscripted by 1 or something like that. That's done automatically by the reading software because the reading software understands MathML through this add-on called Mathcat.
And the second audio was really good. It even did solve the problem of the segmentation problem. In natural language processing, you call this segmentation problem. You detect the boundary, so you know where one structure begins and where it ends, and then you add a little bit of pause in between. So it's it's audibly clear. Thanks.
Yeah. Okay. So I'm done. Ulrike, your turn. Shall I unplug? Or does it give it? It's okay? Good. Du brauchst dieses Ding, das ist ein meiner, der hilft nicht. Du brauchst den von denen. Der Pointer vorher. Habe ich zu viel versprochen?
Nein, super, super. Alle Beispiele gezeigt.
Ja, ich habe ein paar ausgelassen. Ja. Ich habe 2 ausgelassen. Eins habe ich ausgelassen, wo ich mich...
Hello? Now I'm saying something.
Sure.
Right. So we heard Frank speaking about how tagging improves the accessibility of the PDFs. Now we have Ulrike Fischer, who's going to talk about a LaTeX Tagged PDF project. So Ulrike is part of the LaTeX project team, and over to you, Ulrike.
Yes, hello. So I want to give a bit more details about some of the things that Frank mentioned. Typically, I have now given quite a number of talks about the progress in the Tagged PDF project, and typically I start with a motivation why it is important, but now I can leave out because I think you are convinced that it improves PDFs quite dramatically, and that we really need, and more especially that we need better tagging for math, because math gets really wrong if there is no MathML. The main talk is about the tagging MathML, but I want to start with a few other changes in the Tagged PDF project, so that announcements or improvements that are perhaps also of interest. It's only a bit short. The first topic is about that we are consolidating currently the interface. Tagged PDF started as a package. Someone around 2018 or something like this, and if you wanted to try out tagging with it, you had to load the package and you had to activate it and you had to use some low-level commands. In the next step, then when we started really with the project, we invented the document metadata command as a trigger command which is used at the beginning of a document to show this document wants to use new code, and there we can also add document settings, but this is really, it shows new code. At the beginning it didn't do much on itself, it only offered a keyboard interface, and for example the PDF management had to be loaded first before you could do anything with it, so that was before. The next step was that we integrated at first new code into the document metadata, the PDF management, so you no longer had to load it, it was loaded automatically. And we started with various phases which loaded additional code developed during the tagging project. Here, for example, phase 3. But it's for test phase code, so it was really meant for the development, trying out new code, allowing user to load it, to test it, give feedback, and go to the next step. Then we had more modules because we added support for titles and for math and table. The list got a bit long, and so long that I started to forget which one you need. And so we got, and then always had to tell someone, oh, you forgot this module and you forgot this one. So we invented the latest key, which loaded everything. So always gets the newest stuff. And now the next step that we are doing is that we are kitting this test phase mode. So we think the interface is already quite nice and it works actually, as you have seen, quite well. And so now we are no longer using test phase, so instead we have now a tagging key. And I think this key will stay. This key will load the new code. So the current status here is now, with the current latest release, if you use document metadata at the beginning without key, then it will load the PDF management. It sets the PDF version to 0 because we think this PDF version is much better for tagging. And it sets the font encoding default from OT1 to T1, to 1. Sorry, with PDF LaTeX. I don't think anyone noticed this, but we thought it was time to kit OT1 because it has really some problems. If you use tagging equal off, then it will additionally load all the tagging support code, all the new code that we have for tagging. So similar to the test phase equal latest key. It does more or less the same, but it doesn't activate tagging. If you use tagging equal on, then it will activate tagging additionally. That's the state that you get with the current LaTeX. The next release is in November. We'll the next step. There, if you use document method without a key, it will load all this new code. Not only the PDF management, but also all the new code. So it will be quite similar, tagging equal off or tagging without document metadata without argument will more or less be the same. With tagging on, you activate tagging. As there are people around who use document metadata to get only the PDF management code, which allows you to add XMP metadata and set PDF standards and similar, we are now providing a dedicated package that people can use instead of using document metadata. This package can be loaded inside classes, but at best it is loaded as early as possible. The later you load, the more problems you get, because PDF version, for example, must be set rather early in the document. You can always test this new interfaces on this version if you use LaTeX Dev. We released the Dev version last week, and since then this is online and for testing, and I hope that you really test it because it's a rather big change, because now document metadata loads a large amount of new code, much more than before, and so please test and report back errors. Okay, that was an interface. The next point is that we have released, Joseph has released a new class called LaTeX Talk, which allows you to create accessible tagged presentations. Beamer, the Beamer class used mostly by most people, is simply not accessible, and it has so many problems. We try to add tagging support, but it's really, really hard there, and so we decided to write a new class. If you look at the slides of my talk, and you can look at the tagging, this slide is tagged. There are slides. We are not yet sure if all the tagging is really good for users. We are waiting feedback, but we are really hoping. This class is so new that 6 hours before I uploaded the slides, I still hadn't decided if I write now on Citan or soon on Citan. So, it got. The class requires LaTeX Dev currently, because it needs all the code and it needs all the definitions. So you can only try it out with the newest Dev version or with the next LaTeX release. And it requires naturally the new code and so a document meta declaration before your document. It will test for it and fail if you don't have this. Third short announcement is there's a new tool on Citan called Show PDF Tags. It's a command line application that you have in TeX Live. You can call it on every PDF, and then it will show you the PDF tags in this document. In this case, I'm using it with option XML. To get an XML output, there's another tree view that you can do instead, but XML is typically quite nice. For example, I made it on this. It's now a bit small, probably. Perhaps you can everything see it. It's at start. It shows you the XML structure of the tree, including some of the content. Here, for example, is the text status of the LaTeX project. It doesn't show every content. You can't show images or something like this. They will put question marks or say, here's an image. But it shows you the structure. It shows you that I have a section, a part, a title, and so on. The tagging structure of the tagging, including mass and everything. Quite useful if you really start to create tagged PDF. And now let us get to the main question on tagging of mass, which Frank has already said quite a lot of stuff. When I started somewhere in 2018, 2019, I wrote in the tagged PDF documentation, tagging of mass is a problem. I had seen some examples which partly added structure elements around the mass and with lots of actual text and alternative text, and it looked so that is quite unusual. At first, there were no tool that really show what it does, and the main problem that I couldn't see that any author would ever get into the trouble to mark up a LaTeX source in this way. This was impossible. It was quite clear that we need something to get MathML inside, and that this MathML is then handled by a tool like now Mathcat, who knows how to read MathML. That's not our job to tell in every detail how this should be read. Yeah, that's cannot be the so it's not possible, but how it is done. Could see in Frank's talk that this is not only a question about what should LaTeX do. Naturally, LaTeX, as a producer of PDF, has somehow to add some MathML. But once the MathML is there, the reader must do something with the MathML, must, for example, pass it to the assistive technology. Currently, this is only partly working. Foxit add pass MathML if you put it in as an associated file embedded in the PDF. And Adobe pass it on if you put it in with structure elements. So if you put both in, then both can use it. But what we can do, we can put it twice. We hope in both cases that both will adjust. Both are working on their missing part. So I hope this will change in the future. And other PDF viewer, we naturally will have to convince them to add support for this too. And then naturally the screen reader, when he gets the MathML, must do something with it. This now works since June this year. Now the newest NVDA version takes the MathML and passes it, embeds, uses a Mathcat library to read it. And now we have actually a workflow demonstrated by Frank that can demonstrate that math can be read in a sensible way. But this since June, so we are new. Where are the problems? I spoke tagging with math, but actually it's about tagging with MathML. This requires PDF 2.0 because PDF 1.7 views math as a graphic where you put the description above. That's not usable. Not really, not for a complex math. So PDF 1.7 is not really good for math. We need MathML. Now, PDF 2.0 introduced MathML, and I have here shown you the specification. And I should say this is not a small part of the specification. This is basically everything that PDF 2.0 says about MathML. There is not more in it. It doesn't say. We know there's a namespace. You can use the MathML names as structure elements. That's the first. And you can have if you use it, it should have the MathML namespace, okay? That's a requirement. And it says a bit something about if you use an associated file, then should have a certain relationship. But it doesn't really say much more about how is MathML used in connection with other math structure elements. So the spec is a bit vague. The UA specification has not much more details. There are 2 sentences about math. But it at least says you should use MathML, which is already good. So we had actually to find out quite a lot of details ourselves, or by discussing with a PDF organization what this means, or by discussion with the implementation. One problem here is that PDF didn't really realize MathML is an XML language, but PDF is not. But somehow they thought, or if you say you can use MathML, it looks similar, both are somehow trees, so it should be easy to use the one in the other. But for example, a question that is not really clear, MathML has attributes which are in a no namespace, and the PDF actually requires that such attributes are in the MathML namespace. And so if you try an interpretation from the one to the other, what you do with the namespace, drop it, or use another namespace, so to get some structure and some documentation, mostly David made a long document how we should interpret MathML in connection if we go from PDF to XML. There's a long document for everyone interested in XML and XML interpretation. Look at it, interesting. It is used this, in the show PDF text, where we had to decide when we export to XML what we do with a PDF structure which isn't XML. How do we interpret PDF properties and PDF attributes when we are going to XML. Now let's look at some example. I just want to point out one of the problems, some of the problems you came to math. Here a short example with a cases environment. And we have a line, we have a cases. Here is an absolute x to say the absolute number. Inside math, we have sometimes nested text with, again, nested math. So, oops. This is the text. It should be marked with PDF structure elements. The nested math inside is then again XML. And so we have really to develop solutions. What does this mean and how will Mascot handle this? There can be references with links inside math, which you have to handle too, because these references, in this case, the reference stays inside the math, simply for the example. But reference could go to somewhere else in the document. And you have to handle this too when thinking MathML and PDF. If you want to tag math with associated file. An associated file means you create a MathML version of the equation and you embed this into the PDF and then you attach this PDF to the structure element. As I said, Foxit can handle this type of MathML. To do this, you use document metadata tagging =on. You should at best use Unicode Math because really math tagging works the best with Unicode Math. You should at best use Lua LaTeX because really math tagging works best with Lua LaTeX. And then you have this already will produce a MathML with a LuaML package. It will then embed the resulting MathML. If you want, you can correct the MathML. If it's wrong, you can extend it. And then the code will do embedded in working. That is the default mode that we are currently using, that MathML is embedded with associated file. Cross-references and are not quite clear. And the problem with associated file, they are easier to create and to manipulate, but you cannot really navigate through the math because there is no synchronization between the PDF and the MathML file. There is a MathML file at the beginning of the math, and you only know there at the beginning is the MathML, and you don't know which part of the MathML belong to which part in the PDF. The other option to add MathML is with structure elements, which are inside the PDF. For this, you have to add a tagging setup command, which say use MathML structure elements. As I said, you can also use both. Then you have to say use also MathML RF, and then you get both. And this creates then MathML structure elements. It's more challenging because it has to manipulate the M list and the math list, and embedding structure elements is not so trivial, so not so many environments. There can be more errors, but it will in the end allow you to navigate with the math and to synchronize some subparts of the math with actually MathML. As structure elements are known to since a long time, more readers that actually already pass structure elements to a T will also pass the MathML structure elements. They won't know them, perhaps, because they have no idea of PDF to 0, but they will probably pass them on. So there are more chances that this works with more readers than the associated file method. Nested math and so on, there are still work to do. At last topic here, I want to mention intents. Frank has already said something about it. We want to try. We have already started, but must need some support. What is intended here? I had the apps command, and the apps command should say something like that is meant to be an absolute value. So the MathML should contain, should contain apps. You can define this, we have command for this, but here really you need to redefine commands. If you want to have an intent, you have to redefine them so that they add the intent. The intent, the system of equation that you heard when you wrote the alignment, this is because we already add automatically intent, an intent system of equation around the line. We also add intents around the label, which was read very well. I don't know if you have really realized, but it said system of equations, row 1 with label to 1 from the end, and then it started. And this is because from our tagging with the intent, which tells Muscat, here is a label. That was made together with the author of Muscat, so that labels are really read in a well. So intents are really important because they improve the reading. Also, someone just mentioned that there was a nice pause between the two steps of the alignments. And the pause is inserted through an intent. There's really an intent, say, make a pause here. And stop a bit so that you can read it. So intents are really important, and they will be done much more. We will try to improve many of them commands so that intents are inserted everywhere. At the beginning, the PDF specification, the ones say where it's not vague, it say use MathML 3. Well, we won't do this. We will use MathML core and not MathML 3, and because we want intents. So that won't do that. But intents are work in progress. I thank you for your attention.
Any questions?
Hello, thanks, Plato. It was very good. I'm wondering about the document metadata command that you added, and you said you're pretty happy with the interface, and that will probably stay that way.
Could you say louder?
Yeah, sorry. You said that you were pretty happy with the interface you've settled on with document metadata, and then you had the tagging equals on there.
Yeah.
I'm guessing my question is, could we get to a point where you don't even need that command, you just turn it on by default? Or maybe the related question, is bad tagging worse than no tagging? Like, do we need to be confident architect the whole thing?
There are two questions here. The question is, should tagging equal on be the default or tagging equal off? That is something that will be to be discussed. Perhaps at some time tagging equal on will be the default, and if you don't want it, you will have to switch it off. That is, currently we allow tagging perhaps makes errors, and perhaps it's if someone has simply document metadata, he should have the choice to switch it really on. The other question is if we need the document metadata command for itself. This is quite clear we need it because it loads lots of new code. And we cannot simply load this new code on all old documents. Because it changes things. It changes spacing, it changes the handling of some environments. It is not compatible with quite a lot of packages yet, even if it's compatible with So really, this is like the switch from LaTeX to 9 to LaTeX to E, where a new command from document style to document class were introduced, so that people who didn't want to switch had the chance to stay in the old system. This LaTeX has some backward compatibility, and so we need people to have the chance to say, no, I don't want this. Yeah, so we give. The new code will always need this document metadata command. It has also it is useful because you want to set standards and PDF version and so on. It's the begin of the document, and at some time you will also be able to set the author or the title in this place, so that really the main document metadata are at the begin of your document.
I have one question from the chat and one question from me. From the chat, Werner Lemberg asks, what is the time horizon of the tagging development?
Time,
yes. When?
Oh, well, how sure. That depends, on many stuff.
Well, I mean, the time horizon is that we have now valid tagging possibilities already today, with a restriction of usable of 600 packages and not every class. But if you restrict yourself, you get full tagging support today. It is still under development, meaning that the inner stuff is going to change, but for standard documents that only use these 600 packages, you have tagging if you want it. Now, when are we going to be finished? That will certainly be more than, really finished more than 2 years. If not more, it depends a little bit on, we need to be ending up with basically every important package being tagging aware. And important means that it is used by a large fraction of people. And then we can hope that new packages start to be wanting to be tagging aware if everybody needs tagging. By now, we have requirements all over the world that accessibility has to be there. So the need is growing, and you can serve the need now, but only with a restricted set of LaTeX documents.
The user actually clarified that he meant the basics like MathML support rather than all the packages. So he basically asked about MathML.
The MathML, this is we showed it. This is actually already working.
Yeah.
There, you will probably still get errors with the one or the other command or with the one or the other math package who does current definitions, and there will be improvement. But the core MathML and the ASM, I think I tagged the whole IMS math documentation, and with the exception of one curious stuff, it compiles and is tagged. Yeah, so we have a large amount of MathML working. Complex stuff like diagrams or so, they are even more because how to read them and how to make them. But the core RMS math is working.
And a question from me, if allowed. As a package and class writer, what is the best way to check whether document metadata is in the user document? So when I start my class, I want to understand whether the user started document metadata. Is there a switch?
That is the reason why we now start to load all the code. Before, it was very difficult for a class also to understand which code was loaded, because document metadata only loaded the PDF management, and then people could use various phases and various combinations of modules, and a class also had no really good chance to know what is going on. Now that we are loading everything, you can test first. You only need to test if document metadata together with is the format new enough. So if you test for the combination of document meta and format, then you know this new code is there. And test of tagging is active or not is something that you actually shouldn't do, because you should use tagging sockets and they should switch on or switch off depending if tagging is there or not.
What is a package level command?
If document metadata TF.
Thank you.
But ask me if you want. And you can also force document metadata. This is what LaTeX talk is doing. There's a command, needs document metadata, and if it's not there, it will error. Yeah, and we tell you this document needs document metadata. So now, from now on, from the next release on, package and class authors can reliably test is new code there or new code there. It will still change a new code. Yeah, new code means something that's changed. So do not expect everything to stay. Yeah. So test. And,
Any more questions? Thank you, Ulrich.
In Kerala.
The next talk is a remotely delivered talk by Ross Moore, where he will talk about tagging with regard to highly structured documents. So Ross Moore has been a member of TUG since the 1990s, having first joined the TUG board in 1997. This year he stepped down to allow some fresh blood to come in, and he is the joint author of the XY-PIG package, and has worked on the PDFX package for many years at the request of CVR and Han Tethan. So the talk will start now.
In Kerala and watching online. Can't actually make it to Kerala this time, but this online presentation will give you pretty much what I wanted to talk about. But firstly, I want to thank CVR in particular for past hospitality and visits to the River Valley campus, and I was very pleased to be able to find this photograph online. Tagging of structured bibliographic data. What is it that we want with this? Well, the easiest way to show that is with an explicit example. So that's what I'm going to do. I'll switch to an example document. And watching online. Can't actually make it to Kerala this time, but this online presentation will give you pretty much what I wanted to talk about. But firstly, I want to thank CVR in particular for past hospitality and visits to the River Valley campus, and I was very pleased to be able to find this photograph online. Tagging of structured bibliographic data. What is it that we want with this? Well, the easiest way to show that is with an explicit example. So that's what I'm going to do. I'll switch to an example document and we'll see the kinds of stuff that we can do with tagging. Okay, so here's the document that we want to look at. You can see for the bookmarks here that there are 10, 11 sections, and each of these sections has a bibliography. So let's have a look at it in the tagging view. And the first bibliography occurs here. But what is the structure of a bibliography? Well, it's a kind of a section. Tagging here is sect. It has a title and it has a list. In this case, just two elements in the list. And each list item has a label. This is using author year style, and so the label is made up of the author and the year with a little bit of punctuation in between and at the end, and you can see the actual values of the author field and the value of the year field. The L body for the list entry, well, it consists of more information, which is bibliographic information. So it has the standard tag of bib entry, And Miller et al. 2023 was the key, the bibliography key that was used in generating this bibliography element. And it has the fields, the heading, some punctuation, the journal title, punctuation, which is just a space, volume number, some more punctuation, and a page, a starting page in this case. Some punctuation, and then followed by a DOI, which is a reference to an external location. So that one only had 2 entries. If we look in section 2, we have a larger bibliography. It's here. And again, title, the list of entries, all the different bib items, and they are all structured in a similar way. This one is an article, the title here. This title is interesting in that it also has a bit of extra text which is in a different style, and so that gets tagged separately. All these names, bib-title, bib-journal title, they're custom style names, but they are all in fact role mapped to span, and so when you export this into another format, they'll be treated as just spans of text, which is how they appear in the visual view of the bibliography. So here's a picture which is of a different part of this, a different bibliography, but it shows the correspondence between the information and the information that's supplied by the author in the file bib.tech, which BibLaTeX uses, putting together what it needs and then further processing it. Each of the different fields is here with the name. One thing that is slightly different is that the journal, instead of just being the name, instead of being just bib-journal, it's bib-journal title, because at some point in the BibLaTeX processing, that name has been changed. But the data is the same. The data is the correct data. The long DOI field here is something that I've defined myself, which is used for making sure that, well, okay, if you look back at what's happening up here, if you put the DOI starting there, then the link would cut across the end of the line, and so it forces an extra line break before the DOI is placed. It's easier to do the tagging of a link this way than it is to allow the link to break across lines. Well, here's a view of what happens when such a bibliography is part of a derivation into HTML from this document. And you can see what's happening here. The label is at the top and it's indented to the left with respect to the rest of the information. Here I'm using a web inspector view to show the actual HTML tagging as well as the result up the top. How do we achieve this kind of tagging? So we need to discuss that. And okay, if one looks here, I'm showing a section of the documentation for BibLaTeX. These guys, Philipp Keim, Moritz Wemheuer, and Philippe Lehmann, they've done a fantastic job with BibLaTeX. So they have this concept of blocks of units and punctuation between units. Okay, so we've seen a fair bit of that already. The main thing is that the blocks consist of several of the fields, and each of those fields is treated as a separate unit. So unit here is being used, in a sense, as a technical term. And then this documentation mentions various macros, and which need to come at certain places. And these are important to us. When it comes to actually printing the results or printing the information, then these ones, print text, print field, print list, print names, bib string, these are all very important. And it turns out that we're going to need to patch some of these. In order to do that tagging that I showed you, you need to patch some of these to some extent. There's 2 pages there, so there's two images. How things done in BibLaTeX. they use these drivers, a bibliography driver. So this is an example of the bibliography driver for book. This is taking the actual source out of the package file. And you can see how certain kinds of fields are grouped together. So if you like, that's a block. Okay, here's an example of how the print command would start. There's a testing whether the field is defined or not. If it's not defined, you don't do anything. If it is defined, then you want to print the field. But the point I want to make here is that there are so many of these driver files for all the different types of entries, and they can vary with different bibliography styles, that there's no way that you would ever be wanting to try to patch all of these. There's so many of them, and you don't even know whether the information is there or not in any particular entry. So patching at this level just is not on. In order to try and understand this a little bit better, I wanted to get some pictures that illustrate some of the concepts. And so the idea of blocks of units, well, I came up with this idea. In Australia, we call an apartment building a block of units. People live in separate units of the places where the people live. In other countries, you might call those apartments. And the block, well, usually they're quite tall, several levels, and well, that's all the apartment building, let's say. Or another way of supposing a family was having a special holiday, special family reunion, where all different members of the family, the cousins and the uncles and grandparents and all of that, were all going off to stay at a motel or booked into a holiday resort, and you'd make a block booking of units for each of the families that are coming, or one family would make a block booking and another family would make their own block booking. So that's the kind of idea that I wanted to capture. And then I thought, well, okay, it's census day and you're collecting information. I want to draw an analogy there between the bibliographic information and collecting information for a census. If we abstract that a little bit further, maybe it's a single household and the individual units could be the people that are involved there, and the blocks would be related to the kinds of work that they were doing in that house or how they were related to the head of the house. So I found this lovely old picture from the 1861 census, and you see the head of the household is filling in a register and getting information, recording information for all the different people. Here's the kind of information that they're filling out, but this one is actually pretty special. If you can read this, it says Buckingham Palace and Her Majesty Victoria. This is Queen Victoria. This is a photograph of the actual register that was filled out in the census of the year 1851, taking place at Buckingham Palace. The block and unit structure, well, okay, you've got the block. These are all the immediate family, and the Queen and Albert, this should be, and Prince of Wales. But this is the one I like the most. This is more modern, and you can see how complicated the collection of information can be. And on the right-hand side, I want to contrast that with a driver file for, say, the report documents, just giving us an idea of the complications of the information that we're having to deal with. So what do we actually do? Well, we need to identify the places in the code that's being executed by BibLaTeX where we can add in extra stuff to do the structural tagging. We need to also place things into the content stream, designating the start and end of each piece of content, which includes punctuations. And so we need to identify where these places are, and we either need to put hooks there or somehow patch an existing macro, giving it an opportunity to do some extra work as well as what it would normally do. And so in the next slides, we want to identify these places, and this will end up involving an idea that we call hierarchical patching. What I'm not going to do is show the explicit coding to do everything, because different people will be doing tagging in different ways. There's the LaTeX. LaTeX is developing tagging, which will be available to everybody eventually, but current pre-press houses like River Valley have produced their own way of doing tagging, and I've also produced my way of doing tagging. So I'm not going to show you the details of that, but showing how to find and to establish appropriate places for hooks, and say something about the BibLaTeX macros which do need to be patched, but patched within a context so that they work when they need to work, but just allow BibLaTeX to do what it naturally needs to do in cases where you are not doing any tagging. So we've seen how the basic piece of information that needs to be set is in a unit. So this is how a unit begins. BLX at big unit, so the beginning of a unit, and you can see there are tests to basically say, are we going to need this information or do we not need it, and what to do. So often what to do is nothing if you don't need it, but if you do need it, then there could be punctuation to finish off the field that you've previously set and it hasn't been closed off yet, or there could be special stuff happening giving the relationship between what this new unit is and what came previously. But in fact, there's really only one place that needs to be patched, and that's down here. And it's marked here as a mode switch. What I mean by that is that leave vmode, well, LaTeX has a macro called /leave vmode, and it's used when you are finishing a block of information that's been collected vertically and starting something which is going to be stacked horizontally, or in other words, you're starting a new paragraph or maybe just a single sentence, and so you're switching from vertical mode to horizontal mode. So quite clearly, if you're going to be doing that, then this is a place where you've finished all that vertical stuff, and so any tagging associated with that can be closed off, and you're starting new stuff, so you can prepare for the new stuff. It turns out that BLX at leave vmode is used in other places as well as just here within the beginning of a unit, so you actually need to check that your leave vmode is being followed by begin group, so that this is in fact the place where you're at. And so you're going to need a macro, so this is going to be the name of the macro that's going to end up replacing this. It looks ahead for the next token and then examines that token. So that's what this part does. It examines that token. If that token is begin group, then we are going to do something which is clearly related to creating hooks to allow us to do tagging. If it's not begin group, then just do what you otherwise would have done with leave vmode. And then for the unit hooks, what can we do? Well, it's the definition involves a pattern which picks up the word begin group, so it picks up that begin group. We know it's coming because we wouldn't be here otherwise. We can put in here a hook which allows us to do what we need to do with respect to structure. Then we do the usual thing that leave vmode would do, and then we do our begin group. So we're just doing what this would have done if there was no patching here. And then before we actually get to the content, we can now have another hook, which is to be used for setting up for patching content. So that leaves us with two things that need to be done. At some point, we need to capture the original meaning of leave vmode, and then at some point, we need to assign a new meaning to BLX at leave vmode, which is going to do our macro that checks out that we're at the right place and then provides us with the hooks when that's where we are. And then tagging is done via those hook macros. Okay, so the structure at hook, it sets up our tagging for a structure, and that structure needs a name, and so it gets that name from the value of a field which that our coding defines. It should have a value at this stage, so we need to check out how that gets the value, but we'll look at that in the next slide. The content hook, it can have further hooks which can allow you to adapt for, if you like, field-specific variation in how the content, punctuation, and bibliography strings are to be handled. There's two of these. One of them depends just on the field value itself, the other the field value and the entry type, okay, because different entry types might handle the same information in different ways. We need both of these. And it turns out that we also need to have an extra hook back up here in the structure, and I call this pre-hook, because in certain entry types and certain field names, there could be stuff that needs to be done before you actually provide the new structure. Okay, so this is a very special one. It's not used very much, but I have found instances where it was necessary to use a hook here. So how do we get that name? Well, here's the coding, the BibLaTeX coding for print field. Print field is an alias for an internal macro, BLX at internal macro print field, and it first does a check, basically saying, well, if you give me the name of the field, is it actually defined for our particular entry here? And if the answer is no, then there's nothing to do, no unit. Otherwise, we want to work out, well, how is this supposed to be handled? What's the format of the information? What's going to control it? And so it checks, puts all the stuff together and works out whether there's a value to this, which is going to tell us how to do the formatting. And that formatting is down here. So once we've established what the formatting should be, it gets fed the value of the field content, which comes out of this kind of structure. And of course, we have to begin the unit. Yeah, sorry, that's a mistake. That shouldn't be next slide. It was previous slide. We've already looked at that on the previous slide. What we need to do is we need to patch this particular command in order to pick up what that field name is, store it in a place that which we can then use. And we saw this on the previous slide, how we needed this when working out how to tag the structure. There's more stuff you can do at this point, but then you go and do what this should have done in the first place, or what it's intended to do if there wasn't any tagging. So we've inserted new processing before the coding does what it normally would do, and this is all happening at a place which is appropriate. Now, how do we get all this stuff working? We need to patch this to that, make this call up that instead of do what it normally does. So we need some coding which tells it to make that switch, and where should that happen. To determine that, we go back and have a look at what happens when we call up a bib item. When we encounter a bib item in the bibliography, the pink numbers here indicate as many as 9 different places where you might consider you'd be able to do something. It turns out that you really only need to patch at one place, and that's here. If we had numbered labels, so a different kind of bibliography style, well, we don't do that in author year, so this one is actually not used, and so we can actually ignore this, okay? However, if we were going to use numbered styles, well, then we probably would want to put something around here. But in our case, we don't. So it turns out that there's really only the one place that needs to be patched, and that is what happens at this stage. And this is effectively where you get, right, remember we're in a list of items, and so this is where the item command comes in, and so it's where we're beginning a new item in a list, and so something definitely should be done at that point. If we have a macro like this, okay, we really only need one single macro here, but it's a very complicated one. It has a complicated pattern. Okay, so here's our big language bib. So in other words, everything in here is going to be picked up as the number 1. Then between big language bib and page tracker, that's going to be our number 2, this bib sentence there. And then our number 3 is going to be all this stuff here in blue, which is where the actual driver content is processed down to the end lang bib. So that complicated pattern is matched, and we're picking up 3 parameters. What we're going to replace this with is something which sets everything up for the tagging of our list item. Then it does what it normally would have done. It then does the number 1 and the beginning language bib and the number 2 and the page tracker. After that, we set up for the L body, and that includes a parameter which is in fact the field name title. There's something that needs to be done there. There'll be complicated coding involved. And then we do everything else for finishing off the L body, because everything else is happening in this blue stuff. Okay, so that's what happens there as the number 3, and then we finish off the L body, finish the language, and then finishing off the list item, the tagging of the list item itself. So that's complicated macro, but it can go in there and handle all of the tasks that need to be done. And the important ones are starting the list item, starting the body of the list item, finishing off the body, and then finishing off the list item. Obviously 4 important things that need to be done with respect to tagging. So we saw how print field gets picked up to give us the name of the field. Turns out there's actually 5 things there that need to be patched in the same way. So there's the internal if field undef, and then there's a shortened version which actually does the same thing, but it needs to be patched as well. For lists, there's the if list undef, the internal version and the shortened version, and then we have a collection of names, and there's the if name undef that needs to be redefined, or at least the internal version, in order to simply to pick up the name of the field and maybe do a few other things that aren't going to affect the typesetting in any way before checking whether we actually need this for anything. A few other things that need to be changed, that need to be patched: bib string, wrap bib string, and also print text. I'm going to skip over the punctuation details because we'll be running short on time, but there's some examples here of where different amounts of punctuation are used. And, well, it turns out that we need to get the punctuation correct. The idea with the punctuation is that you really you don't want to have separate tagging of all bits of punctuation. You'd like some of them to be combined. If they're adjacent to each other, you want things to be combined. And in order to achieve that, to get the nicest effect, then a lot of things need to be looked at. There's more detailed tagging. So the actual details of that tagging I'm not going to discuss, just to give an indication of some of what you can do here, right? So here, if the punctuation was something like add colon, add space, if that's what our punctuation macro expands into, then we want to replace it with a tagged version. Okay, so colon, add space, tagged version. And similarly, add comma, add space, we want to replace that with a tagged version. So that you'd have this kind of macro you might use at some appropriate place. And again, styling in titles, we saw how we could have styles in titles. We saw how we can do that. So this gives some other examples. Here's a little bit of what looks like mathematical notation. It's actually for chemical symbols, but we can pick that up and handle that appropriately. And here's another case with, okay, so this is interesting. The overall style of the title is italic already, and you're wanting to put in another italic part, just like it was up here. So you don't see the difference visually, but structurally it is there. A summary of patching. So here's our hierarchical patching idea. We need to set up the subsection, which handles the bibliography as a whole. Start the environment, the bibliography environment, finish the bibliography environment, So these things need to be patched. But in the patching of this, we can then do further patching of what's going to occur within that bibliography environment. So we have to patch the @bibitem command, and that also needs an adjustment to another internal bibliotex command. And item of bibliography. Okay, we saw how that was needed to create that pattern with the three separate arguments in between particular macro names. So we need to get that into place. This provides us with the prepare for L body for LI and prepare for L body, and each of those does various things. So here's some of the punctuation that needs to be patched. We saw where the finish at L body was used and where the finish at LI is used. Okay, so we needed those in place, and then the preparing for L body is we need these to be patched, and various other ones that need to be patched. So that's the kind of hierarchical patching idea. So that's pretty much all I wanted to say, but except maybe what else can be done. Okay, there's BibLaTeX has this concept of entry sets. We haven't done that yet. We haven't implemented tagging for those. Other bibliography styles, we can do work on doing those. We've only done author year at the moment. The more cases that we actually encounter, we may find more things that need to be done. So more hooks that need to be defined, work out what needs to be done in various special cases. Okay, another idea is to provide expanded text for common abbreviations. If the word is to be spoken out, you might as well say the whole word volume rather than vol dot. And for eds dot, you might just read out the word editors. And for this one, what is it going to say? You prefer to hear the word lines, because that's what that abbreviation stands for. And then, of course, there can be an adaptation into different languages. Right, BibLaTeX handles that. We haven't tried to do any special tagging for that yet. So that's pretty much all that I wanted to say. So thank you, everyone. And I hope I've given you a reasonable understanding of the kind of stuff that can be done. Thank you.
Ross has joined us online, so if any of you have a question, you can ask now.
Rose, can you hear us?
This could you hear us?
Okay. Sorry, can you hear me now?
Hear us?
Very well, yes.
Yeah. Yes. Okay. Great. Yeah. Sorry, I was watching the YouTube video, and it seems to be out of whack with what you're seeing. So, yeah, I'm ready for questions now.
So this bibliography tagging.
Yes.
What is the XML output that you will get through these references? The PDF tagged PDF.
Well, I'm not directly doing XML tagging. I'm doing PDF tagging, and so But if you do use Acrobat and do a save as XML from Acrobat, the XML tagging is actually very, very good. But of course, there is no schema that it's meant to satisfy. It'll use those structure names that we made up as custom structures, which are bib dash followed by the field name, and then the data from the field will be there. So
it's possible to get back to.
It's not specific.
It's
not geared. Yeah, sorry, not geared for it. Not. Well, yeah. I mean, you should then be able to take that into BibTeX, and it will probably work. I mean, you may have to do a little bit of adjustment, remove that bib dash prefix at the front, but it should. The intention is that kind of thing should work. You should be able to write a tool to make that work.
Okay, that's it. So I was just wondering whether BibTeX is the standard or is there something else? I was just wondering.
No, it's just using the, well, okay, BibLaTeX changed one of the field names, right? So instead of journal, it became journal title. That was part of the BibLaTeX processing. But if you want to extract it out to make a valid BibTeX file, then one of the things you do is change journal title back to being just journal. That's,
Yeah, there's so many.
You've got to do some work. You don't get everything for nothing. You've got to you have to do a bit of work, depending on what it is you want.
Any other questions?
Hello. So
yeah. Hi.
So the question is something like connected to the earlier one, something like that of it's work only for the bib data file, am I right?
Yeah. My talk title was this is a case study. So this is what I've done to show how, and the main point of it is to indicate the places where you need to do extra stuff in order to get the tagging working. Right? That was the whole point of it. In fact, that was basically in response to a question that CVR asked to the TUG organizer, or to the TUG board. He had mentioned that BibLaTeX was something that he found particularly difficult to work with, and so I've decided to, since I'd actually done a little bit of stuff with BibLaTeX, I decided to do a lot more, and I was showing you that kind of stuff, right? So identifying the way, there's no simple patching. You have to do a much more complicated patching than just what you do for a single environment, because you've got all of these fields which are related to each other in complicated ways. And they have all this extra punctuation between them. You have extra words that BibLaTeX puts in itself, or your bibliography style puts in itself. And you need to identify what is stuff that was provided through the original fields and what is stuff that has been provided by the package itself. And you want to make sure you can tell which is which.
And one more connected question is something like that of when the PDF is tagged with this bib data or bib, the command what you embedded, bib label and all. So in that case, the readers can recognize the command and read it appropriately, or something need to be developed on the application side, Foxit reader or Adobe side.
I'm sorry, I think you're asking me to do a bit more than what I've said I was doing. I'm just, right, so this is meant to be a talk to show people who didn't yet understand why tagging is necessary or why it's useful. I think in Frank's talk, he showed exactly what that is. And in my talk, I'm showing you how you can do an awful lot more than just what you need in order to make sense of ordinary information. This is highly structured information, and you can make an awful lot of headway with making sense of that as well.
Any more questions? Thank you, Ross.
Okay. Well, thank you, everyone. Thank you.
So now we have a break for around 20 minutes. The next talk is scheduled to start at 4:10.
Okay. Okay, thanks.
Hello. Okay. എവിടെ ഇരുന്നാൽ മതിയോ? ഇരുന്നാണ്. ഇവിടെ ഉണ്ടല്ലോ. ഇതിന്റെ ശല്യം ഇല്ലായിരിക്കാനാണ് ഞാൻ പ്രത്യേകിച്ചത്. അതുകൊണ്ട് ഞാൻ മറിഞ്ഞിട്ട് ഇത് കാണാൻ വേണം. എനിക്ക് 15 മിനിറ്റ് മതി. സാധനം മതി. എങ്ങനെയാണ് അതിൻ്റെ പരിപാടി?
ലെഫ്റ്റ് റൈറ്റ്. ഇത് ഇൻ കേസ് സാറിന് ലേസർ ചെയ്യണമെങ്കിൽ
എനിക്ക് ഭയങ്കര പാട്. ഇത് ഫോർവേഡ് ബാക്ക്വേഡ്.
അതെ.
എവിടെയാണ് ചെയ്യേണ്ടത്?
സാർ
പോയിന്റ്
സാർ വെറുതെ എങ്ങനെ ചെയ്താൽ മതി, മാറിക്കോ.
Everyone, welcome back. The next talk is by C.V. Radhakrishnan, also known as CVR, who is a long-time tech developer and is currently working for STM Docs, a company that is hosting this TUG. He has also organized TUG conferences in 2002 and 2011, and he will be talking about archiving Malayalam content in this talk. Over to you, sir.
Thank you, Jubilee. So, my talk is centered around the state of digital archiving in India, and with special reference to Kerala, and how to use tech and related infrastructure to generate archival versions of Malayalam content. And also, I will describe briefly, very briefly, in a qualitative fashion about the principles involved and methodologies and the workflow in general. So I will not be going deep into the technical side or the macro part of the workflow or the packages. Coming to the question of archiving in India, also in Kerala, people are not at all worried about the archival, but digital archiving part of the content. Even the publishers are not worried about it. I mean, I'm talking about the Indian publishers or the local publishers. Except for the international publishers and the people working for the international publishers, nobody is having any idea about what digital archiving means or what the longevity of the document sources or reusability of the sources or future-proof formats of the contents. Even the government and the universities, which in other parts of the world are very much interested into that, but in our place, it's not the case. They're hardly interested in archiving the content that we are having. People generally believe that the ultimate culmination of the content is the print. And it's always centered around creating a print version. And in most of the languages in India, still the PageMaker, it's an obsolete software, still runs and still goes there. Even I doubt even Unicode is percolates into many parts of India. That's the kind of situation here. And also they store the sources in very obsolete file formats, like PageMaker. The best example is the Hort's Malabaricus. It's a 12-volume Latin treatise on the flora of the Malabar coast. Recently, our university, not recently, 1.5 decade ago, our university published the Malayalam translation of this valuable collection of books. And at that time, they used PageMaker to create the print version, and they printed and released it, and it sold like anything. And after some time, they stored the files in PageMaker format. And after 1.5 decade, they found mistakes and they wanted to release a second edition of the Hortus Malabaricus. And when they tried to open the system which is used to generate the second edition, it failed miserably. And the content could not be properly retrieved, and they could not do anything at all. Then somehow they captured the data, then the whole editorial process had to be run afresh. It's a huge task with human effort. And then they published it. But the sad part of that is, even then, the publisher is hesitant to think about the long-term preservation of the source data in future-proof formats. And after 10 years, this is going to repeat again and again. And also, they totally disregard the longevity or reusability of the data, of the sources. And also, there is another problem. Recently, we had natural calamities like floods in Kerala. In most of the year, it's repeating and repeating. In 2018, the flood was very, very disastrous. And we lost very rare collections of books once for all, which we have lost eternally. And there is no digital copy available for those things. Now, around 86,000 manuscripts reside in our manuscript library of the university. And so also, an estimated equal number of books, printed books, are available, which none of them have got a digital archival format. This is very disastrous, but in other part of the world, things are quite different. Even the dissertations have been digitized and all those things are available. But here it is entirely different. So it is at this situation that we, a few volunteers of the Sayana Foundation, which is a non-profit, working here in Trivandrum, engaged in open access publishing of publicly available content, decided to create software and showcase the best practices so that others distribute the software and others can make use of it following our model if they think it is good. And as you can imagine, Sayana Foundation uses check and related infrastructure for its own creation of digital formats in PDF and whatever. So that was the main reason why we chose TUG as a means of generation of digital formats. Our decades-long experience in TUG and XML was the main reason. So also the programmability of TUG and the ability of TUG to generate different kinds of PDFs for immediate human access, and also XML from the same LaTeX sources. And apart from this, the possibility of automation intertwined with the usage of free software is also one of the biggest reasons to make use of TUG. It goes well with our ambition to distribute the software, which means there is no vendor locking. We are not locked to any proprietary software. It's completely free and open. So we can freely distribute among the community and they can make use of it. This is also one of the reasons why we use TUG to generate the XML. And it also brings in the possibility of the community, the user community, to improvise it, to add more features, etc., etc. So these are the main reasons why we chose TUG. And TUG is very excellent for creation of high quality printed books. It can create good quality PDFs for printing. But the highly powerful macro language of TUG creates a lot of hurdles on the way of creating XML from a text source, because both follow different grammar and different structure. That's the main problem with TUG. But generally people have devised several methods of creation of XML format from LaTeX sources. And some of I will describe 1 or 3 different kinds of this process. Now, the first one is the parsing of the LaTeX sources and emit an XML out of that, which is mainly used by LaTeXML and Thalix. In that case, you have to re-implement TUG that can understand the macros, the functions, various packages, and then properly output the XML elements and attributes at the correct locations, which is a huge task. But still then, it can bring you surprises at times, and you have to, it's an ongoing process because the packages are getting developed every day and revised every day, and it's always a moving target. And the second method is DWA-based stuff, which TUG Forestry kind of software follow. TUG Forestry follows this method follows a different kind of method, where TUG compiler is used as a translator, which means you need to create, just a customization layer over and above what is available already for TUG or LaTeX. So you need to inject some sort of the elements and the attributes at appropriate locations in the DWA output as special commands, which means you won't see it on the output, but it will be there. Then you do a post-processing, perform a post-processing with which you can extract the text as well as the embedded XML elements and attributes, which gives you an excellent result. In our experience and at our work, we have been using TUG Forestry at least for some 20 years, and it gives us excellent results so far as any kind of XML or any kind of complex XML, or including mathematics, and you can customize to any level. That's one of the biggest possibilities of this second method. And there is another method where you create a variant marker, which is in XML, which look like or simulate the LaTeX structure. And then you apply XSLT to create a LaTeX output or an XML output, which whatever you want. But this is primarily used by author community. Some of the authors might be technically savvy, and they can create such documents, and they can publish the PDF as well as an HTML onto the web. So these are all some of the methods which I know, or we know. And we always chose the second method, DWA-based injection of XML elements and attributes, and then extraction from the output, which we are quite familiar, and that is easy for us. But however, this cannot be directly applied to our language, because when we started the work, say around 12 years ago, or 30 years ago, TUG Forestry didn't support complex script. or Unicode. Hence, we have to devise some other method to do that, which I will shortly explain. So now the question of XML DTD, the choice of XML DTD. There are several popular DTDs available. We deliberated on JADS, which is very quite common and community supported. Then DocBook, which is popularly used by Linux people for their documentation. And then elsewhere, XML DTD. Although you cannot make changes there, but you can use it. It's as in freeware, you can use it. And then comes text encoding and interchange, that's the TEI, which is used by European Union and most of the humanities people. So at last we chose TEI DTD because most of our work are related to humanities, or literature, or politics, economics, and those kind of things, and fiction. So it's better that we go for TEI DTD. And it caters a wide variety of content types. You can use it for simple article or even technical content because it supports mathematics and MathML. And it supports linguistics, lexicon, grammar, whatnot, and even movie scripts. So the range is huge, and we have such kind of data with us. So TEI might be the best option for us to do the job. And there's a community-supported software infrastructure is also there, available for TEI DTD. You all know Sebastian Dars, and he was working for the TEI consortium, and he has contributed enormously to the TEI cause. So you can translate to TEI XML from different sources, and also you can translate the XML sources into different kinds of formats also. So software is available, and even if you're amateur, you can make use of it. And it supports the nuances of the humanities, what the humanities scholars demand. Like the manuscript description, the manuscript might be a palm leaf one, and you might have got different locations, got different types of different versions of palm leaf manuscripts from different locations of the state or the country, and each might be having a little bit of differences between them, and TEI DTD provides to capture those differences and note it properly. And that's a big advantage of using the TEI DTD. And then critical apparatus, which is something connected with the semantic meaning variations, and if you have over the years or over the century, usage has changed. You can note that originally what was the usage, what the meaning of the phrase, and what is the meaning of the phrase at the moment, and you can record all those things. And these are all necessary for the humanities, and so that's why we went for this TEI. And it has got also exhaustive metadata, which most of the, of course, the Elsevier DTD has excellent metadata, but so also JAS, but it will never come nowhere near this TEI. It is quite huge, and you can do a lot of things that if your metadata is exhaustive, you can do a lot of things. You can capture a lot of things. And also it has got superb documentation. I thought that tag by tag is the best documentation I have ever read. But this is something of 2,800 pages, huge. The volume doesn't make it better, but it explains a lot of things. And also, Science Foundation wants to publish a digital lexicon. And TEI helps that also, and it's well documented. So these are all the advantages of making use of this TEI DTD. Now, coming to this question, there is a workflow and how we will create that. I told that we cannot directly apply tech forestry for generation of XML DTD, XML from Malayalam documents. So what we did was, instead of creating a DVA, we created a PDF using LaTeX, which supports Malayalam. And the output will simulate or mimic the XML structure. I will just show you an example of that. You can see that. So this is a PDF. This is not a text file. This is a PDF. I created a PDF like that. So from this PDF, we apply PDF to text, a small program, which extracts the text alone from that. And also a small regular expression is also applied, because just to remove the spurious spaces and empty elements. And it generates TI encoded XML. And this XML is parsed against the DTD, and if it passes the DTD and parsing, HTML is derived from that. If it doesn't pass the parsing, then we again go back to the editor. We edit it, locate the error, fix it, and again repeat the process. That way, it is repeated until we get a fully parsable XML, TI encoded XML. That's what we do. The same LaTeX source is used for generating PDF for printing, which is a straightforward business, and also a PDF optimized for reading on the phone screen. And the general structure of TI DTD, we need to have a general idea of what the TI DTD demands from us. So it has got mainly two elements. That's the one is the TI header, as the name indicates, the metadata, and then the text. These are the main two elements. And the text has got front, body, and back. The name tells you what it holds. And then there is a synodata, which is it's not mandatory, but it's optional, which can hold, it's a container, if any changes in the alphabets used or scripts used, or some of the scripts may not be used these days. For example, in Malayalam, we have these Malayalam numerals. The old books, all the old books are having Malayalam numerals, which none of us are able to read it now. So we need to use Arabic numerals in its place. And here in this synodata, we can keep what are all the characters and what transformed into some other stuff, some other character, some other script. And even it can keep a regular expression also. And then revision history, which is nothing, it's a history of the revision, history of the digital document. And if you look into the TI header, it has got a few important elements also. File description, which it says that title statement, and then which has the title, author, and the names of the responsible persons, like who captured the data, who proofread it, who cleaned up, or who encoded it, and those kind of things. And the publication statement, which is nothing but exhaustive bibliographic information about the digital document, digital XML. And then source description, the original source info. And then encoding description, which is the relationship between source and digital text. If a standard spelling is used or modernized spelling is used instead of the old spelling, and you can have what process has been used and what software is used to generate such kind of things, which we can all keep all this information also in the XML. And then profile description, non-bibliographic aspects of them, like the language use or subset of a language used, and the historic context in which the book was written, such kind of things. These are all the general structure of the TI DTD. And TI header is very exhaustive, and the ordinary standard LaTeX document doesn't provide that much of information to create the TI header. So this is a problem for us. So we thought we will have an extra input file which will have all the metadata information by defining definitive LaTeX commands, and we will keep all this information as its arguments. And then we just create a redefinition spree. I mean, the environments are easier because it has got a start, a begin element, and an end element, which is so easy to do. And slowly, I mean, in the next slide, I will explain about, I'll show an example about how a simple macro is defined. And the packages are modularized so that the maintenance is easier. And in the right side, you can see there's a hub, the master package, the TUG style, and then the meta. Then there's a front, there's a body, the figure, table, back, and also hooks. So hooks is, at that time, there were no hooks when we started. Then later on, L3 introduced the hooks mechanism, and just a basic hooks thing is there. As I told before, the environments are easier to redefine. So the renewal document environment, for example, the quote is there, and you simply say quote, and the end can have the closing quote. And if there's a par is started again, and whatever is the DTD demands. But the commands that doesn't have a end thing, like section or chapter or part or item or bibitem, and there you need to find the end of the chunk of text, which you know to think about that and write clever macros. The heading in the LaTeX is highlighting that argument so that it catches the attention. It says that this is the heading. But in XML, it's always a chunk of text, a logical chunk of text. So if you look into the right side, the example is there. There's a body, then there's a diff, which is the logical chunk of text in the TUG, and the attribute is there's a part, and inside the part there's a chapter, and inside the chapter you have the section, and then a section closes, and another section starts, and that section closes, and the chapter closes, and then part closes, and then body closes. I mean, that logical closure should be there in sequential order, nested order, which is very difficult. I mean, when you are thinking about symbol redefinition of the LaTeX macros. But there you have to think about it and do the thing a little bit cleverly. And as I told before, the XML is validated by XML lint, and if it passes the validation, and we create the XML from that by making use of XSLT plus Saxon libraries. And PDF for printing from LaTeX, PDF is generated for printing is also generated, which is nothing but a straightforward thing. And PDF optimized for smartphone screen is from the same LaTeX sources. A special package is written for that to allow variable page length. I make use of Boris's algorithm for that, and that helped us a lot. And each section is a page, because otherwise you will have hundreds of pages in a screen. So each section might be longer or smaller, and if it is longer, the page will be longer. The limit is the limitation of imposed by the PDF specification. So that is very popular among our readers. I mean, it is being released most of the days. At least one document or one short story or one poem is released most of the days, and we have released hundreds and hundreds of documents like that, and which is very popular among people because they can easily read over the phone, and without moving this way and that way, is cleanly formatted for the optimized for the screen. So it's generally this good. And the whole process is automated by making use of the makefile and a few targets, and it goes as a breeze in our system, in the GNU Linux system. And the right side, I'm having an example of that, as we see in the page HTML, a a snippet of the HTML, as we see in the work. This is the example of the screen PDF, smartphone PDF. Each column is a page in that. And there's the XML, TUG XML version of that. And there's the metadata, and that's the part of the real data. And now we will come to the limitations of this system. This is a very simple, tricky job. This is not an exhaustive theme. Although we created something like XML of 86,000 pages of Malayalam content by 2-3 volunteers for over the years, and the work is still continuing. It doesn't support maths, which is the biggest limitation. But for Malayalam content, not many math books are there, so it's not an immediate requirement, but still it doesn't support. But it imposes a big limitation on us. We have a 16th century book called Yukti Bhasha, which is a treatise on astronomy written in Malayalam. It predates Isaac Newton 2 centuries. And we couldn't archive it. It has got mathematics like this in Malayalam. It uses Malayalam notation for mathematics. And we couldn't archive it till now, and which we need to do. And thorough rewrite of the hook style is necessary, but now the hook module is exhaustive now in L3, which we should make use of that. And the good point is, Tech Forestry now supports complex scripts. So probably we might rewrite the entire process, throwing out the Lua LaTeX pathway, and instead we will use the real DVI based extraction method using Tech Forestry. And also we have a problem of unwanted ligature formation in certain combination of consonants. Very few, but we need to examine that. For that we are applying the regular expression just to fix that. And for these things, we solicit support from the user community. So the data with the entire packages, examples, and basic documentation are available here in this URL, and the license is LPPL, and the example site that can be viewed at our main site, books.sayana.org, where so many other things are also there. The slide is there, not right. Yeah, we're coming to the end of the story. This is the colophon, and I used this presentation by check. Most of the people did the same thing, but still I just kept a colophon. LaTeX is the compiler, and Beaver is the class. I don't know how it is pronounced, Moloch or Moloch? Moloch. Yeah, Moloch. Okay. It's a theme used, written by Johan Dahlsen, and Source Sans Pro is the main font used. Now I'm concluding my talk, and if there are questions, I've tried to answer.
It's not a question or something like that. Just want to understand the purpose of this is an archive material you are going to do. It's not about a newly created material or something like that. If my
No, it's not a newly created step.
Not a newly created, am I right?
Actually, for Malayalam, we newly created it. I mean, you mean the software?
No, I'm talking about the software. You have a copy editing in the process, am I right?
Oh yeah, the Malayalam content, and we are getting from OCR, we are getting from some other sources, we are getting maybe even checkpoints, and then you need a copy editing kind of thing. And of course, the OCR might inject some unwanted stuff into that, because the books are always old and it can have impurity. Some sort of things will be there, and it can create junk characters, even Arabic or Japanese, whatnot. And then you need to clean up it and copy edit it, and their own punctuation marks might be different. Those kind of things, yeah.
Because of archive, I thought, why do we need to have that step? That's it.
Okay.
Thank you very much for the presentation. And I deeply appreciate your desire to archive this process of digital archiving to preserve the texts which are there in the Indic languages. What I'm going to say now is not a comment, nor is it a suggestion, but it is just food for thought. We have to think about it and discuss about it. Most of the, as you mentioned about the astronomical text.
Yeah.
Yeah.
Yukti Bhasha.
Huh?
Yukti Bhasha.
Yukti Bhasha.
Yeah.
So there are a lot of such texts in different fields of science in India. Many of them in Sanskrit, some in other languages, etc. So when an author writes a text, he has his own thought process, how he writes or how he presents the text. So instead of relying on a Western methodology to understand the math which is involved in those texts, I would like that we invest time and efforts and energy in doing research to understand the author's way of presenting the text. There are so many examples. Vedic mathematics is there. A lot of astronomical texts are there, like that. This is my humble, neither a suggestion nor a comment, but it is just a food for thought.
Okay.
Thank you. Thank you.
So
I don't know whether you know there is an initiative in Stanford, Stanford Initiative on Language Inclusion and Conservation in Old and New Media. They are mostly interested in the languages which are threatening extinction, and Malayalam, of course, is very popular, but I never realized that you have problems with preserving literature in Malayalam. I wonder whether you can contact them. They have a lot of interest in such things, a lot of knowledge, and they put a lot of effort. Maybe you would be interested in contacting them.
Yeah, of course. Yeah, we'll be. Surely.
We will talk offline about this, and I can give you.
So, as I understand it, you have quite an involved workflow to extract structured information out of the LaTeX source files. And previously, we've heard a talk by Frank and Ulrike about the tagging project, which is trying, when you enable the tagging, the tags and the structure of the document are included directly in the document, and you can extract it as an XML using the show tag PDF tool, which was also mentioned. Wouldn't this be easier for you? Have you considered using tools such as this instead of going through the generating a LaTeX document which includes the XML tags visually, and then scraping the XML from the document, and so on? You also mentioned that there is no support for math in your workflow, and as Frank has shown, the tagging project supports math, so I was just wondering if it wouldn't be both easier and also more feature complete for you. Thank you.
Yeah, that's a possibility. I mean, when we started around 14 years ago, at that time, we didn't think about such things. I mean, it's only recently we were all discussing about these kind of things. And when we started, and it was an intimate requirement at that time, we have to do, otherwise a lot of books are being destroyed by natural calamities and things like that. So we immediately did something. I mean, that's the thing. And now we can improvise and take into consideration of all the suggestions raised now. I mean, commented out now, like Brajaraja and you. Yeah, we will think about all those things and we'll go forward. Because only 3 persons are working on it and very few volunteers. Still it is volunteer type. And their jobs are different. they might have a little bit of time. Still we could manage to create some 6,000 of pages, and which I think is still remarkable.
Thank you.
Thank you, Sivya.
Thank you very much.
The next talk is by Doris Beren. She has been a member of the tech community for more than 20 years and has served as the treasurer of the German-speaking tech user group for the last 9 years. She has now switched to the TUG board, and in her main job, she is the manager of the CryptTool project, which, among other things, develop web apps for cryptography. In this talk, she will talk about how CATech is used in her project for displaying math formulas in the browser. Over to you, ma'am.
Okay, so hello and welcome to my talk about how we use LaTeX in the CryptTool project. Before I begin, I want to thank the organizers as well as Carl in the US for giving me the opportunity to give this talk and providing help during the preparation. While I can be present here, I want to point out that I'm a mathematician and not a programmer. It is important to me to name Bernd Busse, who cannot be here. He is the main developer at our team and had a great part in preparing this talk, as well as the preprint that is in the booklet. We both work at University of the Federal Armed Forces, which in German is called Bundeswehr, at Munich. Then this here, .com, stands for Data Protection and Compliance, which is our professorship at the Research Institute Code, which itself belongs to the Department of Computer Science there. I cite from the website, the Research Institute Code is a central scientific research facility of the University of the Bundeswehr Munich and uses its expertise to create innovation in the field of cyber IT for the Bundeswehr. We conduct both basic and application-oriented research and technology development in the fields of cyber defense, smart data, and quantum technology for the benefit of society and, of course, the Bundeswehr. Having said this, let's move on to CryptTool. Okay. If you look at this table of content, you will find that I mostly will follow the preprint, but I chose to also talk about two of our sub-projects, namely the CryptTool book and historical cryptography. This I decided because I think that those would be interesting for this audience. Okay. The QR code leads you to our landing page. See the screenshot on the right. You can start to explore our sub-projects if you click on the icons on the left here. Depending on your device, the icons could be hidden in a burger menu on the top left. I will not go through all of them. The green one on top, the O stands for Cryptool Online. This is where we use KTag, on which I will focus on later. Here you have an overview of our sub-projects. As the name already suggests, we offer tools for cryptography. They are free of cost and advertising, and we do not collect personal data. We were fully open source once, but not anymore because unfriendly actors copied our whole webpage, flooded it with ads, and we had to deal with angry messages from all our user base over the world. So we stopped this. But feel free to send us an email and we give you access to our private GitHub repository if you want to do research or otherwise want to contribute to the project or are just interested in the code. We are really open to do that. Our work splits into maintenance of existing software and development of new products. In the last years, we focused mainly on mobile-friendly, responsive online web apps. Let's begin with the Cryptool book, which of course was written in LaTeX. The Cryptool book was my personal entry point to the Cryptool project. I got to know the author, Bernhard Esslinger, at a Dante meeting. I overworked quite old sources, which came from different authors, partly from the 90s. They used outdated packages and stuff, so it was a lot of work to bring this kind of up to date. There were many listings that had to be customized, and I will go into this on the next slide. Here you have an overview. You can also find this project on the main page. If you go to the Cryptool book on the main page of our project and you scroll down, you will see that every green line is some additional free material. We wanted to keep offering open access to as much as possible. So you can find a lot of linked material here. For example, we have an introduction into the command line interface of OpenSSL. We also have an online app built with WebAssembly where you can apply OpenSSL. It's quite liked. And we also have a Sage Math intro. I, as a mathematician, enjoyed very much testing and typesetting all the Sage Math scripts. There are 140 of them, and you can download them here. We have a free access chapter on historical cryptography or cryptology, written by the members of the Decrypt project. I will give a link later. This screenshot shows the Sage Math code of the Caesar cipher in the Cryptool book. The German version is on the left, the English version on the right. Since Artec House, the publisher, wanted to reduce pages, The code on the right side is missing the comment. We included as comments the output that should occur on your terminal for every script in the German version. From a tech point of view, those listing environments were quite some challenge for me, especially to not let them float and get automatic page breaks like this here with an appropriate continued text. My experience as a LaTeX user around 2020 when I did this was often that different packages interfered quite a lot. So I had to study this author had used this package in 1915 and then or 2015 and then okay, now there is a new package and the new package is better and then I tried out the new package, but the new package does interfere with another package and so on. So I had to read a lot about packages. Okay. Now to historical cryptography. I added some slides about this because I think it's interesting for typography. By the way, cryptology is the right term, but most people say cryptography. The latter, however, does not include cryptanalysis, but focuses on how and why cryptographic procedures work and not how they can be attacked. If you go to the website of the Decrypt project, you will e.g. also find a database of historical manuscripts, which was built by this group. And you also can find there the lost letters of Mary Stuart. Perhaps some of you heard about those letters. The Cryptool project maintains CTTS, the Cryptool transcriber and solver, which was developed by George Lasry for deciphering those letters. It facilitates the manual transcription of historical encrypted texts into digital, machine, and human-readable format. It has many cryptanalysis features, e.g. a graphical interface for symbol segmentation. Mary Stuart used so-called homophonic substitution. On the bottom right of the slide, I included some helpful links for getting you started. For example, the famous Zodiac Killer cipher is also a homophonic one, and you can try to solve it with one of our apps. Now let's get to some website statistics. We use Umami because it's general data protection regulation compliant. Could you play the first video, please? You have to click on the picture, and then it should open. Okay, good. As you can see, we have about 1K visitors per day. We can switch to the last 7 days and identify the weekends, which was 5th and 6th July. This is a pre-recorded video. There is not so much going on. You can scroll down and see the most popular subpages, like OpenSSL or also step by step. And you can see how our visitors found us, mostly Google, but also ChatGPT. Then you can see the used browsers and OSs. And we can also see the visitors' countries, e.g. India occupies the 3rd place. Thank you. We can go back to the slide now. Okay. So, of course, Umami is free and open source. Now let's switch to mathematical typesetting in the browser. There are 3 common ways to generate mathematical typesetting in the browser, which are MathJax, KTag, and MathML. MathML, we already heard today a lot of it, is an XML dialect, and it describes math in angle bracket syntax. It's a subset of HTML5. Here is a minimal example of the Pythagoras theorem that I generated by ChatGPT. And here you have a list of elements. For example, we already saw today the Ni, which is like here for the B. MathML apparently has not fully caught on in web development pages because it was kept too general and therefore was never implemented consistently. With MathML Core, this is supposed to improve. Now to the other two technologies for typesetting math in the browser, which is KTag and MathChecks. Both KTag and MathChecks are based on JavaScript. You can see that MathChecks is written in TypeScript. TypeScript is basically just JavaScript with a transpiler for pre-processing, e.g. JavaScript lacks static type checking. MathChecks supports more LaTeX commands, but we don't need the very complex LaTeX features in cryptool. KTag is faster, and that is the main reason why we use it in the project. I included a time comparison link on this slide, but we will not try it out because of time constraints of this talk. You can click on it later and try it. The GitHub commits over time perhaps do not really indicate much because we do not know how large those commits are. But anyway, you can see more recent activity in the KTag group. Now to the command line interface. If we call the KTag via the command line interface, we can generate HTML files for in-browser rendering. I have a video, perhaps the video 2. Click on it. Always click on the image. Just click on the image. Yes. Thanks. Okay. So I generate a KTag environment. I change there, and as you see, it's empty. Then the node package manager is initialized. Now you have a JSON file here. Then I install KTag. Could it be that we do not see the whole video? Yes, thanks. Now KTag is installed. We have a distribution. We open this file. It's the entry point for the console. It just has about 250 lines. So this is not the real KTag. When we go to the distribution folder, there is also a KTag JavaScript, and if we open this, this is the real file, which also has a lot of lines, as you see. And then there is a minimized version, which has no white spaces and renamed all the variables to be shorter, because then for being transferred through the web, it's better. Okay. You also have a source file, because perhaps you want to compile all of this by yourself, and then you can generate your distribution, but it's pre-compiled. Thank you. And then the next video shows how you use the command line interface. You call npx KTag. And then there is no prompt, which perhaps is a little bit confusing. You just type your formula and then Control D, and this is what comes to the standard output. You can pipe it into a file, which I call here Python HTML. Do the same, but then it's saved to a file. And when you open it, you see it's the same 2 lines. Then you can open this with a browser. And this is MathML. It's a fallback for accessibility. And this is the KTAG output, but without any CSS. So it's not typeset as we want it. This is the same file I just showed in the VI. So what I do next is I copy this file and add the loading of the CSS file, which then renders the KTAG. Then I again open this. And now you have to be fast. When I compare the two files, look at the letter B. So this is the new one. The MathML accessibility fallback is missing now, and it's rendered like it should be. And here you have this from before. And this is how it should look like with CSS. The first was without. Okay, thank you. So this is how I can use the command line. It's quite good documented. It's not so hard. Before going to how we use it, because we do not use inside browser rendering, I give a short introduction about our technologies of our web project. I will not go into all of those because it would take too long. You can read it up in the preprint. Let me just mention that our apps are built from so-called React components. React is a JavaScript library developed and maintained by Meta since 2011, and it was open sourced in 2013. Here is our technology. This is a part of our documentation on GitHub. We have quite well documented everything because often we have students programming little apps and they have to read up the stuff. Later I will show one of those components. Okay. Also here I will not go into detail. In short, we use pre-styled components from, again, a library which is called Chakra UI, and some of our own custom written components. E.g., our KTAG component, I will show a video later, is a custom written component. The full code is included in the preprint. You can find it in the conference booklet if you are interested. Now, how we use KTAG. When we search for KTAG in our GitHub repository, there are only 4 matching files. But when we build the website locally as a developer or also on our server, of course, then there are more, like this listing shows, quite a bunch. You can just, it's similar to what I already showed. You can install it. First, you have to download it from our GitHub repo and so on. And then we have a Webpack which extracts every necessary rules and then optimizes it, concatenates it into a single bundle, which then can be transferred through the web fast. We will now show 2 videos. The first one goes through our example component, shown in listing 6 in the preprint. Yes, okay. Now here on the left, you have the code, and on the right, the output. Here we import our KTAG component. And also this is a little helper we wrote for being able to write escape sequences like that. Also this is one of our own written component. Then we can define a formula as a constant, which is this one. We can use expressions with a dollar sign, which is not a LaTeX dollar, but a template expression. And then this gets evaluated to 2. As you can see here, this 2 comes from this. Then we use our tag component, which produces now this. Or we can use a block environment. The string then is rendered directly with a display look. We also can hand over the aligned. And then you get this aligned formula. Or we can change it to just align, and then as you can see, we have numbering now. So it adapts. Additionally, we can specify styling parameters that are used for Chakra UI, like this here. The white space no wrap makes that it doesn't break into a new line, which it would otherwise do because of the narrow width. If we left that out, as you can see, it would wrap. Thanks. Now the video should be finished. Okay. So this was an example, and now please play the next video. This shows the component KTAG. In line 6. Okay. We see the import of the KTAG from the distribution. Our actual component is located further down, starting at line 64. It receives several parameters, some of which we've just seen. For example, children and math are important for the actual content, and with block we can pass the parameters for the environment. Now let's move up again. Here we have use environment. Basically all it does is wrap a begin and end environment around the string if we want to use such a display math environment. If that's not the case, we simply return the content. Now in line 80, with this content, we can now continue working and use the KTAG, use KTAG function. This function is also custom written and is located further up. Let's briefly look at it too. Here the actual KTAG render to string is called. We see that the text string and the options are passed as parameters, and returned is the HTML string. If an error occurs, we generate an error message. The result in line 80, we now finally can write into the web page in React, line 98, using dangerously set inner HTML, even if it's statically rendered. We are only working with static content here. What we see above in line 92 are things for error handling so that we can display errors. Finally, if we move up again to line 13, it's important to see that we import the CSS at the top. That means whenever we use this component, the associated CSS is also loaded. Okay, thank you. You can close the video. Okay. Now, again, I will show some code of the component RSA. If you want to look it up in Cryptool Online, RSA Step by Step is a web app where you can try out this cryptographic procedure. It's quite famous. Okay. Wait. Yeah, okay. KTAG in CTO also comes up inside of Markdown, and we use Markdown here if we have text in our apps. One of our smaller apps, RSA Step by Step, is available here, as already said. And we will now watch a video again, which shows how those interact. So this is a file. Here you can see the content on the left, which is written in Markdown. Here we import our KTAG component. We can already see in the first paragraph in line 20 how we use it with Markdown. For instance, here the P and Q, they occur here. When we go to step 1, here, the P is rendered using our tag component. If we further scroll down, we see that the values for P and Q are substituted by those that are currently inside the input field. Here. And if we change it, you can see that it instantly adapts. Now to step 2.1. Here is the corresponding code block. What happens here is that we have this encryption exponent 17. And from a medical point of view, it has to be co-prime to the Euler function of the so-called RSA modulus n. And so we have to ensure that the user gets some warning if he chooses the wrong E. And this is implemented here. Okay, thank you. So I'm nearly done. This is my last slide. At the moment, we only use the default fonts, but we would prefer to switch to sans serif math because the other fonts are also in sans serif. The screenshot shows what's there in KTAG at the moment. Sans serif, that's all. I included some links. I won't go into it. But if somebody is an expert in this and wants to help, any help would be appreciated because this would be the next little project to change the fonts. Okay, so thank you. There are questions. Also, our web developer perhaps is online. If there are questions that I can't answer, perhaps there will.
Okay, so I wanted to ask about the fonts. Which fonts are you currently using? As in, you mentioned that you want to switch to sans serif. So which are the ones you are currently using for text?
Just the default fonts. I guess it's the Roman fonts.
Default
the default,
LaTeX.
The
Defaults of LaTeX?
Yes.
Okay, so, sorry?
Web fonts. Yeah. Yeah. Yeah.
only saying you are speaking about web fonts, not about LaTeX fonts. So we can't tell you from the LaTeX side or TeX side what fonts you should use. You need web font.
So it will. So you mean it will choose the fonts from the user's system?
No. There is a web page on KTAG, and they deliver those fonts. On the last slide, I put those links. You can look them up.
Okay.
So the KTAG has a GitHub page, and there they have a list of the fonts that they use.
Okay. Are they? Okay. Anyway, I just wanted to mention that for sans serif math, there is a recent development in the new computer modern family, and they have a sans serif font now, which matches the Latin modern sans design. So you may check that out. That's the only thing I wanted to mention.
Thanks. Yeah. Yeah. No, we are using serif, and we would like to switch to sans serif.
Just wanted to clarify for people who may not be familiar with KTAG. KTAG uses the TEG mechanism in JavaScript, so it's a transpiler kind of. So it uses EFM font metrics. So if you want to replace it by, you have to recompile KTAG using the new set of fonts so that all the metrics. So it's almost KTAG kind of mimics the LaTeX compiling process completely in JavaScript. So you have to understand the font mechanism in LaTeX to do the whole thing. So you have to start with the font metrics. You have to create, see if you have a new true type font or whatever, you have to create font metrics, then recompile the KTAG, and then it will.
Yeah.
I think right now it uses computer modern, so that's the default.
Thanks.
Any more questions?
Are you planning to also implement other LaTeX-oriented stuff in KTAG, or is it
No,
only
because we
math?
just are using KTAG. We are not developing KTAG.
Oh,
yeah.
I'm sorry.
So
Okay.
we are just implementing KTAG to use it with our apps.
More questions? Thank you, Doris.
Okay, thank you.
So that concludes the set of talks that we had lined up for today. Next talk will be starting at 9 o'clock tomorrow. Also, there is an excursion planned today evening at 6:45 for a guided night tour of the city. There is no registration involved, no fee involved. Those who are interested can show up at the lobby of the hotel at 6:45 today.